All right, so y'all said module 3, so let's do limits. Right, you would have done most of the questions like during the break. If anybody want to go over questions of some of the recent years, I just want to see how the answer was and figure out do that, right? I have to check the page to see some questions I haven't done before. Right, for those who knew, you know how it worked. Well, you might know how it worked, but you have 2.5 hours, then you get our break. Right, so if you have to order food, you can order your food for around 9 and like, right? That's when I get our break, and we get your food. So only to go and buy food. Right, and after that, you have a 2 hours and a 45-minute break, and an hour and a half an hour break, and so on, right? Until we reach 6 o'clock. Right? I think we have to lose some money, right? Check and see how much we have.
Hey, Samar, this class? Samar, this
And it's true.
Yeah.
All right, this now look here and all right, so the first thing I want to start with is limit, right?
Say, yeah.
Yeah, I do it. I don't know. I cannot predict them, but right, you ready?
So you're feeling that question.
Yeah, I give all the I give the full brief already. All right, let's go. You ready? Oh, that's fast now, fast. Oh, me, nah, I. Right, so the first thing we're going to take a look at is limits, right? Let's take a look at limits. Then we do questions on limits, then differentiation and integration, right? What you will recognize is you had the questions in this module is the integration. Right? So we're going to learn more time on the integration. All right, so let's take a look at the concept of limits, right? Right, so let's take a look at what happens at 0. Right, so if I ask you, what's the limit of f of x as x approaches 0? How do you determine the limit? Right, for you to determine the limit, you have to look at two things. You have to take a look as x approaches 0 from the right-hand side, and you have to check and see x approaches 0 from the left-hand side, how the function behaves. Right? Plus means from the right, minus means from the left. Okay? So let's take a look at this here. As we approach 0 from the right-hand side, that's the more than sign, right? As you approach 0, you recognize that the y value is 0. As you approach 0 from the left-hand side, we are approaching a value here, which is also 0. Once these two values are the same, it means that the limit exists, and the answer is 0. Okay? That's the concept of limits, right? You want to see how it approaches from the right and the left. Once they equal, you know that limit exists. That's okay? Nice. One of the problems that we sometimes have is to draw functions that look like this. Well, I need to get some pictures. I'm getting nothing actually. I'll bring some people. Right? Sometimes the problem is to draw functions that look like this. Right? Let us see. Right. So if I said to draw a function that looks like that, that is called a piecewise function, right? The function is split up in two parts, right? When the function is more than 0 and when the function is less than 0. Actually, let's put less than or equal to, right? So the function is not one thing for the entire range, right? It's two things. X when it's more than 0, x squared when it's less than 0. So if I ask you to sketch something like that, right? Of course, here's 0. When the function is more than 0, it looks like this. Y is equal to x. Anybody remember what to do here? What happens at the point is 0 for this part of the function? Does it exist? No. So how you show it? Hollow circle, right? So you use a hollow circle. That's okay? Now, when it's x squared less than or equal to 0, it looks like this. That's okay? But what happens when it equals to 0? Is it defined? Is it defined? Yes, because the equal here, right? 0 squared is 0, so I could color it now. So your function looks like that. That's okay? So you have the straight line part and the quadratic part, right? So this defines this whole function here, right? If you wanted to test, for example, the limit as x approaches 0 of this particular function, right? As it approaches from the right, what we got? As we approach from the right, we get 0 again. As we approach from the left, we get 0 again. Are they the same? Yes. So the answer is 0. Okay with that? Right? So, right, something I want to point out as well. Suppose I give you a function that's a little bit harder. Suppose I give you something that's a little bit harder to draw. Then what you need to be able to do is if you can't draw it, you need to figure out which one to use when you're approaching from the right, which one to use when you're approaching from the left. Right? So real simple. More than is when you're approaching from the right, less than is when you're approaching from the left. Are you okay with that? That's all you need to know. Right? So even if you can't draw it, to approach from the right, you're looking at the more than function, plug 0 in here. Right? If you're approaching from the left, look at the less than, plug 0 in there. That's okay. Next thing they like to ask you about right? They like to ask about continuity. Right? Right? Yeah. So continuity. So how do you show something continuous? Continuous means this. If I wanted to see if something continuous at 0, it shouldn't be a gap here. It should just be able to go smoothly. Right? So continuity, for you to show continuity, number one, we have to show that the limit exists. So we have to do this thing here, right? And make sure the limit exists. Next, we have to make sure, let's say continuity at x equal to a. We have to show the limit exists as x approaches a. Next, we have to show that f of a is defined. And lastly, right, we have to show that these two things equal. The limit as x approaches a of f of x is equal to f of a. Everybody okay with that? So those are the three things that we have to show, and we'll do it by example. All right, so let's take it. All right, right. So let's try this one now. Let's see if this function, let's see if this function is continuous at x equal to 0. Right, so let's do my quick favor, see if we can sketch this. See if we can sketch these two functions. And then yeah, and then let's see what will happen. Try and sketch those two functions then. Wait a minute, first one. And by this, you can't catch this one, right? Because sometimes they get out of catch it. That making sense. Why it's like that's 2. If you have to sketch x plus, plug in 2 values, plug in 2 values, plug in x is 0 and x is 1 or something. Can't sketch it. Be careful, huh? It's x plus 2, right? To sketch x plus 2. Oh, sorry, I didn't put x here. Right? To sketch x plus 2, just plug in 2 values less than 0, right? Like plug in -1 and plug in 0 and -1, right? And sketch it quick. Right? And that's why you get this practice sketching, right? Why we talk about that? Let's get this. I will cut to what you right, so that's what I got. Wait, one more time. Go ahead. I'll bring some people, Amber. I'll bring some more. Please. Yeah. All right, let's go. Let's see how this runs. Right. So x squared, we know what that looks like, right? And it's defined as 0. So I can put a solid circle here and curve. That's okay? That's the part here. For less than 0 now, I need to know what that line will look like. So I just go and do a quick little thing. When x is 0, put 0 in here. Again, y is 2. Right? So I'm going to plot x is 0, y is 2. That's somewhere here. Right? It's not defined as 0. So I put in a hollow circle. And then I'm going to unplug x is -1. When I put -1 in here, I'll get y is 1. Right? Y is 1 is about here, -1 is about here. That's it. Sorry. Yours went this way. Like Shana. Right? So it looks like that. This is what it will look like. You okay with that? Right? Remember to draw anything, to draw any line, you just need 2 points. Right? To draw any line, you just need 2 points, right? All right, so let's go. Let's go with step number 1. Let's go with step number 1. Limit as x approaches 0 of f of x, because we want to see if it continuous at x equals to 0, right? So let's see what will happen. As we approach 0 from the right, the function is 0. That's okay. But as we approach 0 from the left, we start in here. And as we approach 0, the answer is what? 2. Right? Are they the same? Are they the same? So no. The limit of f of x does not exist. So we're done. Once you can't prove this, it's not continuous. All right? Right, but I still want to just do the next step, right? What is f of 0? What is f of 0? Check and see where 0 is defined. Is it defined here? Is it defined here? Is it defined here? No. Right? It's not defined here because here hollow. So there's no value here. But here solid, right? So f of 0 is 0. Of course, they're not equal because they don't exist. Okay? So all you have to say now, it is discontinuous. All right? These two things have to be equal and well, the limit has to exist. How about it? I'm finished. Right? You all don't need this, right? Right, next thing we need to be able to, there are some rules for limits, right? There are some rules for limits that we should know. If I ask you to find the limit of x approaches a, right? K by a function, we can pull k outside. Right? We can pull k outside. It's a constant, so it will not affect the limit. Right? If I give you something like this, the limit of x approaches a of f of x plus and minus g of x, what you can do is you can split them up. Right? Yeah. So if you have two different functions and you add them, you can find the limits individually. Same thing. That's why I have plus and minus here, Matthew. Right? All this in the summary earlier. Those who have the summary understand it, right? But you can still write. I know what you probably want to write. Yeah, the summary is still on the website. Right? Nice. What about if you had to divide or multiply? Same thing, right? If I ask you to find the limit of something like this, right? You don't have to work it out like this. You can do them separately. Find the limit on top and then find the limit underneath. Right? And then work it out individually. Okay? Product is the same thing, right? Same thing for product. There are some rules that we need to remember. Like, for example, what is this here? What is this? 1. And it is tan. Tan theta and theta is what? 1 as well. Right? What's the one with cos? No, it's not cos and theta, it's something else. Cos theta, right? Cos theta minus 1 over theta is equal to 1. Right? Right, in this form. 0 not really useful, the 1 here once again. Right? How do we simplify limits? How do we simplify limits? Number 1, once it's indeterminate, like infinity and infinity, right? Once it's indeterminate, you have two things that you can do. What's the first thing? You have to try factorization. And if that doesn't work, then you divide by the highest power of x. Right? You divide by the highest power. So you have two options. Factorize, right? You factorize, if that does not work, divided by the height power. Right? And you can always check your answer. And you can always check your answer. Right? You can always check your answer by using L'Hopital. And I will show you, right? I'll show you an example. Right, so we need to be able to simplify limits. We need to be able to factorize them and work them out, right? That's it for limits. Let's try some now. Yeah, it's a one, but normally what it just asks us to continue on. What's up? Yes, sorry, this is 0. Sorry, that one is 0. All right, let's start here quickly. I don't know. Or let's just paper sheet. The yellow matter. Let me just work it out. No, I think the 126. Practice same thing. Huh? It's possible. Same thing. Just like plus 9 that was before.
My X is greater than 0. That's probably 0.
Greater than 0. Look, it's still there.
Me get sure now. Me get sure.
Right, check it out there. Find the limit as they approach from the left and as they approach from the right. Ready? Good, ready? All right. Right, as you approach from the left. Right, as you approach from the left, which function you use in the first or the second? Right, because it's less than, right? And you plug in 0 here, and you get in what? And you'll get 3, right? That's okay. So remember, the less than when you approach from the left, more than is when you approach from the right. Right? So as you approach from the left, the answer will be 3. And as you approach from the right, just plug in 0 here, and what you'll get? You'll get. Anybody confused? There you go again. Next part. Next part, determine the value A and B for it to be continuous. Determine the value of A and B for it to be continuous. Try that quick. Right, you want it to be continuous at x equal to 0. I have to try quick, right? So remember, for something continuous, the first rule is what? Right, the right have to be equal to the left. Right, the limit as we approach the right have to be equal to left, so it's easy for you to find B. And then gotta find it. Right, but you still have to write the answer for you, right? Right, what it is.
Is what?
Find out the correct. Right, you have to find a way to represent your solution here, right? Right, so we learned a little while ago that as you approach from the left, the value was 3, right? And as you approach from the right, the value is B. So the only way a limit could exist, right, is if both of them equal. Right? That's the only way the limit could exist is if you approach from the left and you approach from the right, both values are equal. Right? So that means 3 is equal to. That's okay. So we know that this function here now is ax plus 3. Everybody okay with that? Right. So how we going to do? Right? So we satisfy the first rule already, right? The second rule is f of a, which is f of 0, must be defined. F of 0 is what? F of 0 is 3. And then they both have to be equal, which we know already, right? We know the limit at x approaches 0, is 3. So they're equal. So did a affect any of those things? So therefore, a could be any value, right? How do I write that? So a is an element of R. Right? A is an element of R. It means that A could be anything. Right? A is not just one value. A could be anything. All right, so just something small you have to remember. Let's go again. I try a little Taylor series. Try that. How are we going to simplify that? Try that first. Right? Remember, well, not now, for like after lunch, after 12 and 3. Right? That's coffee and water and ramen, right? Pure one. Huh? No, those things. Right? What I give you here. So this one you have a bit tricky here. Right? We have to find a way to break it down, right? You'll recognize the identity 1 minus cos squared. Right? So you have to figure out how you can break it up and then work it out. Right? So you have to do the tricks. 1 minus cos squared is what?
Sine squared.
Sine squared. Right, very much. That's my way. You have to find out if it's really something with something you got to work it out. Right, please, don't make up rules, right? Please don't make up rules. It looks nice, but don't make up rules, right? If it's not a trig rule, do apply it. Right, some of you are going and trying to change them to better. Try it out, right? Right. Watch this here. There's a rule I forgot to show you. Watch this here. There's a rule I will help you with this a little bit, right? I forgot to mention this one. If you have the limits as x approaches a of f of x to the n, right? F of x to the n, what you could do is you could pull the whole power on the outside. Right? Might be helpful, yeah. Right? You can pull the power on the outside and then try. Coming up the way out. Yeah, one more for sure. All right. Let's see what you have. Right? Let's see what you have, right? Right? So if you look here, ready? So the first thing you can do here is write the limits as x approaches 0. 1 minus cos squared is sine squared. So you can write it like this, right? sine squared 2x all over x squared. Right? Now, instead of writing, let's show you this step, right? What I can do now is I can square that entire fraction there. That makes sense? I just do the same thing?
Yeah.
Right? Now, if I use the rule I just showed you there, I can pull the square, the root on the outside, the square on the outside, right? And then it will look like this. Okay, stage 2. Well, that's stage 3. Anybody get lost? Everybody okay? I just pull the square on the outside. Right now, the only way I could use the rule is if this value here and this value is the same. So how do I make them the same? Right. Remember, I can multiply the top by 2. I can multiply the top by 2 and the bottom by 2. That's okay? And then what can I do with the 2? Put the 2 on the outside. So I'll be left with 2 by the limits as x approaches 0 of sine 2x of sine 2x on 2x, all squared. Right? We know that rule there, limits of sine 2x on 2x is 1. So you're going to end up with 2 by 1 squared, which is equal to 4. That's okay? Step by step, how you can work it out, right? Let's go again. Are you okay with that? Are you okay with that? No? How you get lost? I'm going to show you here again, right? Let me show you here again because we haven't seen one like this in recent years, right? Right, so you have the limit at x approaches 0 of sine squared 2x all over x squared. You okay with that? You okay with this? Right? So now what I could do is I could write it like this, right? X approaches 0 of sine 2x on x all squared. These two are the same thing, right? Always remember, right? If you write something here, you should be able to go here back to here. If you can't, then whatever you're doing wrong, right? Now, when I reach here now, I could use this rule here. And I could pull the squared all the way on the outside. Right? Here's why that rule is true. Some of you all might make much sense, but what does squared mean? And squared means you're multiplying this by itself. So, and that's technically like a product. So it's like a product, and I said, let's find the limit twice. Correct? And that makes sense? Yeah? So it's like it's a product, so I can split it up and then find the limit and limit. And then you multiply them. That's why the rule exists, right? Sometimes if you know the why, it might stick in your head a little bit more, right? And then the problem here is I have 2x here. Right? I'm doing this for you. You have 2x here, right? So you have to have 2x here as well. So the only way you could have 2 here is by, right? Is by multiplying by 2 here, multiplying by 2 here. That will not change the value, right? Because that is technically cancel out. Right? And I could take this 2 and pull it out. Right? Sine 2x on 2x. The limit of sine 2x on 2x, x approaches 0, is 1. 2 squared is. Right? Let's go again. Right? That was a paper 3, yeah? That was 2015 paper 3. Right? It's the same question, it's the same kind of thing. I don't think it's something different. Right, did the wrong question. Anybody have the next 2015? I have 2 2015. Anybody have it? All right, let's go again. No, here. Sorry. Here. Let's go again. There's the first 2015, right? 2015 have 2 years. Somewhere it gives up. Right, this means right after limits is first principles and then right? Find the value of E. You don't really need that. Right? To work this out, remember continuity of 2 properties. If the limit exists and if what? If the limit exists and if f of A is defined and they equal. So if you do have things to work out the limits, then ignore the limits. Focus on here. Right? Focus on here. Right? What is f of A? Think of that, right? Don't say it. Think of what f of A and see if that can help you. Think of what f of A and then see if that will help you. Right? See if that can help you find that. Right. A little bit different, that's the way to cover it. There's a paper which I didn't even call, right? So hopefully by the night it's always going to paper. Those who do work great, I'll give it and you can finish your part. All we get for Right. Right, Fitz. What you come up with? Right? They wanted to be continuous at x equal to 0. So what is f of 0? F of 0 is 4. And f of 0 is 4. Correct? Nice. So therefore, right? So therefore, here's the question I'm going to ask. What will the limit as x approaches 0 of sine ax on x be equal to? Push up. Right? What would it be equal to? And be equal to 4, right? Because the limits, right? The limits is equal to the value we defined as. So you have to find a that would make that 4. Right, so you have to find a, right? Right, you can't just write the value, right? You have to show them how you get it, right? You can't just, the answer is 9 and the a is 9. You have to show them how you get a is 9, right? Right, quick. Everybody okay with that? Everybody okay with that line? You okay with that line? Right, so watch this here. The only way that this will work is that underneath here must be a. That's okay? Remember, we have to use these rules here, right? So if here is ax, underneath has to be ax as well. All right. So if we divide by a, we have to also multiply by a. And then we can take a, then we can take the a and put the a outside. So we'll end up with sine ax on ax is equal to 4. This value here is 1. So you'll get a is equal to 4. Right? So although most of you all knew what the answer was, you had to show them how you get it, right? Right? So that's technically how you handle limits. Y'all okay with that?
Yeah.
Right, it have more for you, it have more, but I want to just continue, right? While on the fresh, I want to show you first principles one time. Huh? I have one more. Right, if people want one more, so I'll get them one. Huh? Yeah, begging for one more here. Right, and then we do first principles, I'll give it 3 times, square root, the Trig, and a number, right? And you will go through. The time will be out. Remember, whatever you find in sign out must be underneath as well, right? Next first principle, right? Right, so remember the only way that we can use the rule, is that sine 8x, it must be sine 8x over 8x, correct? It must be 8x over 8x. Everybody okay with that? So the only way that we can get that is by multiplying. The only way we can do that is by multiplying the underneath by 4 and the top by 4. That's okay? Right. Earlier, that's something I've seen some people doing, right? Remember, sine 8x, right? 8x is a closed function. What that means is that you can't take something from the outside and affect 8x. So you can't divide underneath here by 2 and divide inside here by 2. Can't do that. That's okay? You can't do that with the sine function, right? Or tan of plus, or ln, or log. Okay? Can't do that. Right? All we can do there is multiply the top by 4, underneath by 4, and then factor out the 4. So you'll get the limits as x approaches 0 of sine 8x over 8x. Right? And this value here is 1, so the answer is 4. That's okay? Let's take a look at first principles now. Right, so I will show you a general rule and I want you to do 2 more first principles, all right? Right, so how do we differentiate? Right, how do we differentiate? And first principles, dy dx, the limit of h approaches 0, f of x plus h minus f of x all over h. All right, that's the law. Everybody should know the law, right? Let's say I wanted something like this. Let's say I will do x squared plus 4, right? And then I will give you square root of x. Let me make it hard. Make it plus 2. All right, I'll leave it like that. And then I will give you plus 2x, right? So you will try those 2 hard ones, right? I'll do a easy one here. Right? So how do we do limits, right? Sorry, how do we do first principles? So number 1, you have to write back the formula. How do you get f of x plus h? Back each, right? How do you get f of x plus h? Put x plus h in here, right? So you will get x plus h squared plus 4, right? To get your x plus h term, wherever you have x, you put in x plus h. Wherever you have x, you put in x plus h. That's okay? Right? So this is your f of x plus h minus f of x is x squared plus 4. That's okay? So
Wash.
all over h. Come here now.
No.
Right. Expand it out. Right? Expand it out. When you expand it out, what is normally happening in numerator? Anybody remember? What is cancelled? Well, no, in numerator. Normally all the x terms cancel off, right?
Yeah.
If you have x and h, well, those remain. But you want x alone normally cancel off. So let's see. If I expand this out, I'll get x squared plus 2xh plus h squared plus 4. That's here. Minus x squared minus 4. So what you will recognize is that the x squared will cancel, constant will cancel. So you'll normally be left with the terms h in it. That's okay? Now, what do we do? Right? You could factor out h and then cancel, right? So you'll get h by 2x plus h all over h. That's okay? And then the h will cancel. And now you can put your 0 in here. Right? So when h is equal to 0, you'll get 2x plus 0, which is equal to 2x. What's the differential of this? 2x. All right? So I want you to try the third and this. You may have done them already. Right? But try this here. Right? Try not to take a picture and put it in chat. You can't work it out, right? Try to work it out. Then when you stick, if you want to do that, you don't call me. And then about the square root, you would have the rationalize somewhere, right? By the square root. If it's time, you have to multiply by the conjugate. Just change the sign in the middle, right? Right, so when you reach there, the problem is there's nothing you can really do with the numerator. Right, so what you're going to have to do is multiply by the conjugate of the numerator. Right, conjugate means change the sign to a plus. Right, so you multiply by conjugate and then you try to simplify that. Right, after you multiply, things should work out and you can plug in H and 0, right? When you multiply the top, that's like difference of two squares and you'll get x plus h. This by this is x plus h. This by this is x. And you put a minus sign in the middle. Right? So your numerator looks like that. The denominator might look like this, h by this whole thing here. Right? But your numerator looks like that. What will happen here? Well, how many x's? Cancel, right? And then you should see something happening, right? The x's cancel, right? As normally happen. And now you would recognize that the h will cancel. That's okay? When you reach here, what you'll do? When you reach here, what to do? right? Nothing else you could really do. Oh, sorry, there's a square root. Nothing else you could really do, so we could put in each is 0. So you'll get 1 over root x. X plus 0 is x plus root x. Root x plus root x is 2 root x. Anybody get confused? Anybody get confused? Huh? No, no, leave it like. Leave it like that. Your answers are root, you get them back at the root. Try the cost now. Right? Remember, if you're using the cost, you're going to have to use those rules like cost. Right? Two by x. That's 2 by x. That's a right there. It would be 2 by x plus. So now the cost 2 by x. Right, it will be that, right? 2 minutes again, then I'll do it. Yeah. Ready? Hurry up. Give me a minute again. 2 minutes again. Just to make sure you have the right first line, right? Just to make sure that you have the right first line. Right? When you reach here, you have two options. Option number one is to expand this out. Cos A plus B. Right? Option number two is to use the factor formula. Cos A minus cos B. Anyone go to load. Right? Yeah, you have two options, right? Cos A plus B or cos A minus cos B. Factor formula. Anyone you want to load? Oh, yeah. Yeah. Oh. Right. So when you reach here now, you're going to have to find a way to use the rules I gave you earlier. Cos h minus 1 over h. So let's bring the cos together and leave the sign by itself. So you will get the limits as h approaches 0 of cos 2x cos 2h. And I'm bringing this here. Right? I bring these two together. Minus sine 2x sine 2h, right? And I divide them both sets by h. Will you okay with that? So I just bring the cos 2x here and I just shift it around. Right? And I just separated them one time, right? I divided this by h and I divided this by h. Everybody okay with that? So I just split it up one time, right? Right? I just tried to save space. I don't have much more space here, right? Right? What can I do here? Since I have cos 2x here and cos 2x here, I can factor it out, right? So I'll get the limit as h approaches 0 of cos 2x by cos 2h minus 1 over h. See enough? So I can factor out cos 2x and I'll get this, right? Minus. What can I do here? Huh? So I'll get the limit as h approaches 0. Remember there's a product, right?
Yeah.
Right? So question. I will question here as well. This is sine 2x, right? And the limit is h. Will this limit affect sine 2x? I have no h there, right? So that's a constant. Same thing here. Right? So that will be sine 2x limit as h approaches 0 of sine 2h on h. Right? And I can do the same thing here, right? I could pull the cos 2x here. Right? What this is here? What this is here? No, that's 0, right? That's 0, right? Even if I still have to put in a 2, right? I still have to put a 2 here and 2 here. That's okay? But it don't matter, right? Because I will still get 0. And do the same thing here. I put in a 2 here and a 2 here. Correct? Now, I can pull the 2 on the outside, but I'll still get, it don't matter really, I'll still get 0 here. Right? Because the limit of this is 0 minus sine 2x. I'll pull the 2 on the outside. 2 by this is 1. This becomes 0. And I will get 2 by sine 2x. So the final answer is 2 sine. Sorry. Minus 2 sine 2x. Check it and see. Differential of cos is minus sine. Differential of 2x is 2. And then write back the 2x. Yeah. Which one? Yeah. And do what? That one again? I expanded. Yeah. Remember, you can't multiply cos 2x and then if you multiply this out, where you got cos 2x plus cos 2h, can't do that, right? Right? You can't multiply cos by the 2 values, and then that's why I have this rule. Cos a plus b. Confused? Anybody confused? Wait, where you get confused? Okay, right? So I just backed out. And you don't understand why I can put the 2x and sine 2x on the outside, right? Because a constant, right? right? Let's look at some rules of differentiation here. So that's your first principles, right? That's those technically are the types that has come, right? Right? Let's run some differentiation. Let's run through some differentiation. Oh, I'll be the same for them. Huh? About 20 men from the start. That's kind of the region they're going about 20 men. 20 of them. Ready? Right, all this summary, right? We don't want to write it, right? If you don't have the summary, just check my algebra to you, right? It's on the website still. Right, so watch this here. Right? Right, so how do we differentiate? Bring down the power minus 1 from the power. Are you okay with that? So these are the basic rules on how to differentiate, right? So let's do a couple examples just to remind you. What's the differential of what's the differential of 5x cubed? Right? The differential of 5x cubed, bring down the 3, right back the 5, and minus 1 from the power. And you'll end up with 15x squared. Everybody okay with that? Differentiation is multiply and minus. Integration is add and divide. All right? Let's remember those little things, right? Right? How do we differentiate something like this? Suppose I give you 3x minus 1 to the power of 4. How do you differentiate that? Number one, you can do chain rule. Number two, you can do the shortcut method, right? Bring down the power, differentiate inside the bracket, put back the bracket, and minus 1 from power. Are you okay with that? Right? So if you have chain rule, which will give you the same answer, or you have the shortcut method, right? Next, how do we differentiate sine? Differential of sine cos. Differential of cos is minus sine. Differential of tan, sec squared. Differential of sec, well, sec tan, and so on. How you could prove this all, yeah? how you can prove the differential of this? Sec is what? And you can use which rule? Quotient rule. Right? You can use quotient rule and work it out. Right? Might look exactly like this, but you should recognize that sec is 1 on cos and tan is sine on cos. So if you work it out, you'll get sine and cos way. Okay? Right? So that's the way you differentiate those rules there. Right? You don't really have to learn them so much that you can have to prove them. Right? You have your chain rule here, product rule, quotient rule. Right? Chain rule, product rule, quotient rule.
Nothing.
Right? You have your applications. You have your applications of differentiation. Right? Created tangent is dy dx. Created the normal is minus 1 on dy dx. You have your rates of change formula. Suppose I ask for this. Suppose I ask for the rate of change of volume. But you're right. Suppose I ask for the rate of change of volume. How you'll work out that? Right? You'll write dv here. And you'll write dt here. Right? Let's say it's volume and radius. Then you'll write r here and r here. All right. So you need to remember how to find like any function, right? dv dt, dv dx. Right? How do I get dv dr? Right? To get dv dr, we're going to need a equation v in terms of r. Right? We need an equation v in terms of r that we're going to differentiate. Okay with that? So you have some small rules to remember with rates of change, right? The hardest thing in rates of change is to be able to get this equation here. Right? When you get that equation, then you can differentiate and work it out. Right? First sketching, you have to remember how to get the intercepts, the turning points, and the asymptotes, right? And I gave you some rules here. Asymptotes occur on rational functions, right? So to find an asymptote really easy for something rational, all you have to do is take the denominator and make it equal to 0, right? And that value will be your asymptote. Right? For horizontal asymptotes, you have to prove the limits and you have to work it out, right? By the way, remember, you can also find these same things by using the transformations in module 1. Okay? So you don't have to use this technique, you can use the transformations in module 1 to find your asymptotes, right? Stop that. I'm more module 1 thing than a module 3. Right? And then we have to be able to find turning points. Remember? Right? Remember for your turning points, you have to find dy dx and see if it's max, min, or what's the next option? Next option is if it's a point of inflection, right? So before confusing with all that there, let's explain it, right? What should you think? Right? You need to be able to determine if a function is max or min. But the hard part is to determine if it's a point of inflection, right? So if you look here, that's a minimum. Then we have a maximum. Then we have a point of inflection. Okay? So how do we show each one? Right? There are two things that we can do here. There's something called a first derivative test. Right? You'll recognize here that your dy dx is decreasing. Here you would recognize that your dy dx increasing. That's okay? Right? So if you use the first derivative test and there's a change from less than to more than, then you have a minimum point. The next thing you can do is find d2y dx squared. And if it's more than 0, you have a minimum point. That's okay? Yeah? Yeah, that's up. Okay, well, here is the other way around. If you have dy dx more than 0, and then you have dy dx less than 0, right? What you have here is a maximum point, or you could use the second derivative test, right? If you get less than 0 is a max. That's okay? So once you get a sign change, it could be a minimum max. But if you're not getting a sign change, then it could be a point of inflection, right? So for example, if you're getting dy dx more than 0, and again dy dx still being more than 0, point of inflection, right? Right? So you just have to check and see if there's a point of inflection. One of the ways as well is if you get dy dx to be equal to 0, then you have to come and do this. This is not an absolute test, means you can't do this alone to show it's a point of inflection. Okay? If you recognize d2y dx squared equal to 0, you have to take the x value and do the first derivative test. All right? There's something I want to point out as well. Watch this here. Let's say we took dy dx and we make it equal to 0. And we got 3 stationary values here. Let's say we got 2 stationary values. One here, and you got a next stationary value here. Right? And you want to determine using first derivative test if it's a max or min. Right? Or inflection. Here what you can do. Right? If you want to check for x is 1, you need a value on either side. You need a value less than 1, and you need a value more than 1. But here's the problem. Because there is a next stationary point at -1, you cannot, right? You cannot choose a value at -2 when you're proving this. So if you were to choose x is -2, that goes into the next stationary point value, right? So you have to choose a value between here and here. So you can choose 0. Here, you can choose anything you want. That's okay? All okay with that? So a number line might be helpful, right? So you choose the right values when you're doing your first derivative test. Right here, for this one, of course, you can choose -2, and you can choose x is 0. But you can't choose x is 2 and x is -2, because -2 is in the region of the next stationary point. Everybody okay with that? So when you obtain your stationary points, if you have to do a first derivative test, do all those number lines and pick values in between. Okay? Right? So that's your differentiation. Let us try a few. Right? The only thing I left is the parametric, right? But parametric is a chain rule. I'll show you that. Right, we're gonna try one of these. I know there's plenty reading, but all right, we'll come back and do them. Right, we're gonna try one of those, right? Right, first principle, we do that already. Right, that's 2016, right? We do that already. Try this easy one here. Find the equation tangent. That's 2016. It's really easy, but try it quick. Hey, you just play it off. Give it over. Try that quick, find the equation at x equals 3. Thanks, Dario. Right, should be almost done. So your 1 is y minus y1. Right, that's to get the equation, right? So to get the gradient, we need dy dx. Right, dy dx is 6x squared plus 10x minus 1. Plug in x is 3 and you'll get the gradient. How much you got? How much? 83. And then you need to get the y value, right? So when x is 3, y is how much? Plug it in here, right? Plug it in there and find for y. And you're done. Well, that's y. Plug in x is 3 in the first equation, right? Plug in x is 3 in here and you'll get for and you'll solve for y. I'm telling you. When x is 3y is what? Underneath. Underneath. Right? And you're done. Right? Multiply it out.
You gotta find BC.
Yeah, when you multiply it out. But look it up. 141.
Yeah.
Yeah. Let's go again. Right, 2015, number 3, part B. Try that means number 3, part B. There's a little small. Try that please. Next one. Try that there, Aaron. Hurry up. Try that quick. I find volume of a square. I find volume of a square again. 4/3 pi r. Right, go ahead, up one, try this here. Yeah, the 2 centimeter cube per minute. What is that? The what? Rate of change of the volume, right? So that's dV/dt, right? So you have dV/dt. Otherwise, what do they want you to find? The rate of the radius changing, right? So that will be dr/dt. So the way to find dr/dt. Right? Set it up nice. dr/dt is equal to. Set it up, and you have the equation already, so work it out. When they say decreasing, what you do? Let's follow the minus sign, right? Very good. Right, so we need to get drdv. Right, we need to get drdv, but it's much easier to get. It's much easier to get dvdr, right? That's okay. How do we get dvdr? Just differentiate that, right? When you differentiate, you'll end up with 4 pi r squared. That's okay. But we need a value. So what do I substitute for r? Right, because the diameter is 8. So I have to substitute r is 4. Right, you can leave your answer in terms of pi for now. 16 by 4, that's 64 pi. Right? But we want dr dv, so I have to flip it over. Everybody okay with that? We worked out dv dr, right? But we need dr dv. So you have to flip it over. Right? And then you multiply it by, and you get your answer there. Right? Nothing wrong if you leave it in terms of pi, right?
That's fine.
Yeah.
Exactly.
Sorry? Oh, minutes, yeah, that was minutes, yeah. So after the work. Ready? Copy down, let's go again. Right? We ever did channel boost before? No, right? Should we move it? Try and slow that one. Why is that?
Dante, che vedete che fa W in the chat?
Oh, yeah, try that quick. We get in trouble going to part B, but try something on. Right, remember in your exam, you might see something you never see before. See how far you can reach. Try and think of something, you must have to try something. Try something. Anybody have something else? Well, it comes it's something kind of. Alright, so watch this here. Right, so the problem is we don't know how to do tan inverse. Right? Right, we don't know how to do tan inverse. So I'll show you two things that you could try. One of them might be a little cumbersome, right? Huh? Right, so watch this here. One of the ways that we can do it is this, but it's a little bit of working, and I'll show you an easier way, right? One of the ways is as soon as I see that, right? As soon as I see tan inverse 1 minus x squared, I don't know the differential tan inverse, right? But I know that tan inverse is 1 over tan, right? That's okay? And tan is what? Tan is sine 1 minus x. Tan is sine and cos, right? So it'll be sine of this, sine of that over cos of that. And I can flip it over, right? So y is really this. That's okay? That's one option. But the problem with this is that you have to use sort of rule and quotient rule, and you do it twice. There's a second differential they want, right? So we need something a little bit easier. Not much easier, but a little bit easier. As soon as I see this, I don't know how to differentiate tan inverse, but I can differentiate tan inverse, right? So if I move, so you could finish this up, right? This could be U1, this could be V, right? But here's what I know. I know tan. So tan y is equal to 1 minus x squared. That's okay? By the way, if you continue now, this make a little substitution, right? Let u equal to this, and then differentiate it. It'll be a little bit easier, right? Right here. What's the differential of tan? X squared, right? So watch this here. How do we differentiate tan y? What we could do is we could let u equal to y, right? So we'll get tan u, right? What's the differential of tan x squared? Or tan 2x? Let's go easy. What's the differential of tan 2x? 2 differential of 2x's. Differential of tan is, and you write back 2x. What's the differential of tan y? The differential of y is dy dx. Differential of tan is and then you write back here y. What's the differential of 1 minus x squared? Minus 2x. right? So what does that mean? It means that dy dx is equal to minus 2x over x squared y. Can I leave that? Can't leave that. I can't leave x squared y. So I have to find a way to get rid of x squared y, right? What are you going to do? You're going to use 1 plus tan squared y is x squared y. Okay? And 1 plus tan squared is equal to x squared. I know what tan y is. So tan squared will be 1 minus x squared all squared. So I could take this, bring it in here. So dy dx is minus 2x all over this. Yeah, now technically there's a unit to the question. Right? There's a unit 2, so that's probably an error of what it is. Right? But basically it's things that we should know, right? Carry across tan, differential of tan is x squared y, carry across x squared y, and then multiply. All right? And then simplify this and then find second differential. All right? Okay, next part. Right? Before you do second differential, expand this out first, huh? Expand this out first and then do second differential, right? Right? You'll follow what I did here. And to get rid of x squared, I use an identity, right? And I know what tan squared is. Tan is this, so tan squared will be this squared. Go it over again. So I carry across tan inverse and I get tan. The differential of tan y is differentiate y, you get dy dx. Differentiate tan, you get x squared. And you put back the y. Differential of 1 minus x squared is minus 2x. So dy dx move across x squared is this. Right? But the problem is I can't leave it like that. I had to get rid of the y. I know that 1 plus tan squared is x squared. Right? And tan squared is this squared. Right? So I take up tan and I write back this and I square it. So therefore, x squared y is this. Yeah. Right? This identity I use. Right? And then I plug it in and work. Right? Yeah, it's hard. Every now and again, I would drop a hard one. Let's do something easy now with the next part. We're almost done. You guys break this now. Do this here. 1 hour break and start. After 1 hour, right? How do we get dy dx here now? Right? Here's an example of a parametric. So what you'll do. So you have to get what you have to get? So you have to get wait, no, I'm sorry. You gotta get dx dt and dy dt and work it out, right? Check back your rules for parametric, right? So this you can get dx dt here, you can get dy dt. So how would you find dy dx? Huh? How would you get dy dx if you have those two things? Right? So you can find dy dt and divided by dx dt. Right? Technically chain rule. Right? Technical chain rule. Divided just multiply. Ready? Next one. What you all got here? Right, remember? Are you okay with that rule there? Right, remember that? That rule there is nothing new, eh? That is technically chain rule, right? And here will be t and here will be t. But instead of me writing multiply, I write divide. So I'll flip this over. Right? So basically there's the rule here, right? Right? Next, you need to get dx dt. What is dx dt? I got differential of a is 0. Differential of b is what? Differential of b sine t will be b cos t. That's okay? What's the differential of y? What's the differential of y? Minus d sine t. Last part, dy dx. What to do? To get dy dx, you dividing these two, right? So you're dividing minus d sine t by this b cos. Right here, and then you can break it down if you want into the tan. Right, you can break it down. You'll get dy dx is equal to minus d on b minus b on b tan right? Tell have more, tell have more. Find the value of t for which the circle has vertical tangent. What is that?
But it's the x-axis. So not y. Something about the x.
Right, so here's what you're trying to say, right? It have a vertical tangent. Something else you need. And the way to find t. So we probably need to get what dy dx is. So if I give you a vertical line, what is dy dx? Well, what's the grade of a vertical line? Infinity. Grade of a horizontal line is what? Grade of a vertical line is infinity. Right? So here, dy dx is equal to infinity. See if that helpful? See if that helpful, right? Right? Do use this version here. Use this version. Not helpful? Are you okay with this though? Are you okay with a vertical tangent having an infinity gradient? Right? Now the next part. How we go and get them t values? If you have a fraction, right? And the fraction equals to infinity, what do you know? That's all. And if you have a fraction, right? And the fraction equal to infinity, then the denominator is 0. So it means that b cos t is 0. Can you find for t? Right? I know we didn't do trigs yet, but you should be able to do that. Find the values of t. Now we'll give you 0. Value. Sorry, put in radians, right? What that is radians, so okay. Because
T is equal to 1.
Huh?
T is equal to 1.
T is equal to
1.
1.
So, even tomorrow, right? The same.
That's not a good try, but that's not T is 1.
Oh.
Huh?
Oh.
Write it out, we'll work it out quick. Try it quick. 5 and T. Try it quick. Right, solve b cos theta is equal to 0. Right? Put your answer in mediums. Right? Put your answer in mediums.
Oh, you're correct. Let's try something. Do it not one.
Right? Cos t is 0, right? Right? When you move b across, you'll still get 0, right? So t is simply what? Which is?
Pi on 2.
Pi on. Right? Pi on 2. Right. Anybody? Anyway, that's so cool. Anybody remember? I know we didn't revise that yet, but how do you convert how do you take a parametric and get a Cartesian equation? What do you do? Nothing to do with this. What you do? Make one subject formula. T now. Cos and right? Make cos the subject, cos t the subject, sin t the subject, and cos squared t plus sin squared t is 1. Alright? Alright. Take a break off. Right? We'll take a look at this one in module 1. So you'll look at how you sketch that, right? Take a break. 1 hour from now, we start integration. Yeah, you first bring it up. Out.
Then I have to plug in.
Come back. 9 o'clock. Yeah. Come back 9 o'clock.
What shit? Check it out. Hey,
Anybody who's staying here, remember to keep your doors closed now, please.
yeah. Check it, somebody else.
Check one of the back of the Check one back of the
Whatever is mine. You don't know. Hey, hello.
Before the
I want to be on the
I want and I have oh, it's any market, but I
Right, integration time. All right, let's start now, yeah. Right, so first thing that we need to remember here. Right, Darren, next start. Thank you. Right, so integration, remember you can take the constant, pull it outside, right? If you have the integral of two functions, you can do them separately. Right? If you have limits, remember you integrate and then you plug in the b and plug in e. That's okay? If you have limits, right? The integral of b on a is equal to the integral of b on a with respect to t as well, right? Right? I'll show you one of these in a little while. Right, here's the next rule. Right? If you have a, the integral of f of x between a and 0 is the same as, should have an equal sign in the middle here. Same as the integral between a and 0 of f of a of x. If you were, there's an error again. Right? If you were to integrate with respect to a and b, right, you'll get the same integral, but you had a power minus sign in front, right? Right, so just some little rules for you to remember. Then we have basic integration. Whenever you're integrating, yeah, so I'm going to ready? Right. How do we integrate? Real simple. Add 1 to the power, divide by any power, right? So don't forget your plus c there, right? Carry on, now. Right here. How do we integrate ax plus b to the n? Let's give you a small example. Right. How do you integrate that? Right, to integrate this, add 1 to the power, divide by the new power, and divide by the differential inside the bracket, which is 3. And then pay a plus c, right? That's okay? That's the way you integrate things like that, right? Add 1 to the power, divide by the new power, and divide by the differential of the bracket. Integral of sine integral of sine minus cos, integral of cos sine, integral of sec squared tan, and then we have all the others here, right? One of the rules that we sometimes don't see is this rule here. This rule here is sometimes a rule that we don't see. The integral of sine x to the power of n cos x is equal to this. Anybody remember the general form of this rule? What's the general form of this rule? That's the trig version of it. But there's a general form of this rule. Right? That's the general form of this rule, right? F to the n plus 1x over n plus 1. Right? Same thing here. If you have f of x, which is sine x to the power n, then the differential of sine cos. Correct? So therefore, if you look at this rule here, it's the same thing here. F to the n is here, and the differential of f of x cos x. Okay, so look out for that rule, right? Right. Quick example. Tell me what's the integral of sine squared x dot cos x. What's the integral of that using this rule here? It will be sine cube x over 3. Right? So that would be sine cube x over plus c, of course. That's right. So you have to know this, rules, right? Especially the tricks. Next question. Could this be done next week? Could this be done next week? How? Split it up using what? And a product rule for integration. Right? Right. Anybody else? Other guess? What about if we make a substitution? Right? If we make a substitution, let u equal to sine x. Right? You'll end up with the integral of u to the n cos x dot. When you differentiate this, you'll get du dx is equal to cos x. If you rearrange, you will get dx to be du on cos x. And the cost cancel off. That's okay? You're seeing that? So technically it's integration by substitution. Yeah? No? Yeah? No?
Yeah.
Right, just watch it one more time, right? And I'll get to show you I'll get to show you integration by substitution here one time. Right? So if you let u equal to sine x, then you will get du dx. Right? Then I'll get du dx to be equal to cos x. So I'll get dx to be, just rearrange, du over cos x. So I can make these substitutions here, and I'll get the integral of u to the n. Right? This is u to the n, this is cos x, and dx is du on cos x. And it cancels off nicely, and you'll get u to the n dot du. Right? And you can integrate that easily. That'll be u to the n plus 1 over n plus c. I will pick up. That's okay? So one of the types of integration that you are going to have to figure out, right? Or be able to use properly integration by substitution. Right? Let's say they don't tell you what to substitute. How do you figure it out? No. Normally what? Normally what in brackets. Or normally what is done in the C. Right? If you have a square root, normally what is inside there. And pick up. Right? So those are the different types of integration that we have to know, right? Right? Watch this here. If they ask you to integrate sine squared, you have to use your trig identities and convert sine squared to a half minus a half cos 2x. And now we can integrate this. Right? You can't integrate sine squared, right? So integrate sine squared using this rule. Cos squared, this rule, tan squared, this rule. Right? Then you go ahead and you integrate like normal. Right? Whenever you're integrating, and it, right? Whenever you're integrating, what you're really doing is you're finding the area under the curve. All right? So if I ask you to find the area under the curve, that's the formula there. If I ask you to find the area between the curve and the y-axis, you need the limits b and c, and you write it in terms of the y, right? So for example, if I gave you y is equal to x squared between 2 and 4, and I ask you to find the area bounded by the y-axis, it will look like this. Not a question, right?
So seriously, I just know which one is like on top of the
I don't know.
I just know which one is on top of the outside.
Oh, the latter value one. Right? Larger value on top, smaller value underneath, right? Right? I mean, okay with that?
Yeah.
So I need to remember that, right? If they ask you, which they could, find the area bounded by the y-axis, it changes a little, right? They integrate with respect to y. If it's with the x-axis, they integrate with respect to x. Okay?
With respect to it, you mean like
Normal integration, just y is now the variable. Normal integration. Right? Just one thing you need to remember, if your area below the x-axis, what do? Right? You have to modulus the value or just put a minus in front of the integral. Okay? So your modulus between here, or you put a minus, or what else you can do? What else you can do?
you can put A and B.
You can flip the A and B. Right? You can flip these two. And that will naturally give you a minus sign, right? But the only way you can know this is you have to do a little sketching, right? Unless they give you a graph, right? You'll have to do a little sketch. Right? And you'll recognize that you'll see this a lot, find the area under the graph, right? What would happen if they ask you the area in the shaded region here? How do you go ahead? Right. Right. So number one, you may not have A and B. So to get A and B, you have to solve these two functions simultaneously. Right? And then you integrate between those two values, right? The larger function, the one with the larger area divided by the smaller area. Which one here is larger? Now, f of x. This one here. Right? This one here. And the one underneath is the g of x. So you're integrating f of x minus g of x. No need to do them separately, just do them all at once, right? Simplify f of x minus g of x and you're good to go. All right. Of course, you would have seen the recent years, right? Where they give you same thing, two functions, but it's across different axes, right? So you had to pay attention and break it up properly, right? The good thing is they're giving you graphs for now, right? What they can do to make it harder is go give you a graph. You had a choice.
Simple.
Right? Well, if you draw, they'll give you graphs that you can draw x squared and x plus 1 and things. But you have to remember to find all the important things, where they intersect, y intersect, x intersect, all those things, right? Right, then we have the formula for volume rotated around 360 around the x-axis, and then we have it around the y-axis. That's okay. We have to learn those values, and most important that you're kind of guaranteed to see is a differential equation. right? The technique that we are going to use is integration by separation of variables, right? So you separate your variables and you integrate. All right? So I'm gonna start with that. Oh, at this level, they'll give you a real simple. Anyway, I'll show you it now. Right? In unit 2, this makes second order a little bit harder, but unit 1, I'll give you a basic second order.
Yeah.
Right? Right, the reason I started the paper trees is that if you pay attention to paper trees, sometimes you'll see them pop up in paper trees. Right? What I was going to do. Right. So let's say I gave you a differential equation like this. Right? If I gave you a differential equation looking like that, well, you're going to solve it. Nice. Right? So the first thing you write separation of variables. Separation of variables, bring your y on one side and bring it x on one side. And then you integrate. The integral of 3y with respect to y is 3y squared on 2 here. 4x squared on 2 plus c. Right? You don't need to write 2 plus c's because when you move it across, you'll still just get one constant, right? Right? When you reach here though, you still have to make y the subject, right? Carry across the 2, 3, and then square with everything. All right. That's the first order. Oh, one thing I want to go over. Well, not go over, show you, right? Because every now and again it's come. They didn't bring it recently, but what's the integral of that? What's the integral of 1 on x? The integral of 1 on x is ln x. Right? And the general rule is this. The integral of f prime x over f of x. If the numerator is the differential of the denominator, then it's ln. Okay? So if the denominator is the differential of the if the numerator is the differential of the denominator, then the answer is ln f of x. Modulus because have to be positive. So just do the sum here now. Just do 2 real fast. I can do it mentally. What's the integral of that? What would it be? Right? The differential of this is this, right? So that will be ln x squared plus 1. Try one more. What's the integral of that? What's the integral of that? What it's supposed to be? What in numerator is supposed to be? 2x minus 2. By give it x minus 1. So how you can make that 2x minus 2? So you can multiply it by 2. If you do that here, you have to divide by 2. So your answer will be 1/2 ln of this. Right? Right? And if you want to look real smart, you can take off the half here and put it here. Right? And you'll get out. Right? So the differential of this is what? The differential of x squared minus 2x is 2x minus 2, right? I didn't give it that. But you want to get that. So I multiply this by 2 and I divide it by 2. Now the integral of that is what? Ln. Ln of this, right? Let's go back here. Okay? Right. So we're gonna spend some time on these. Sometimes you have to develop it and then solve it. sometimes you could just still give me something to solve, right? I don't know, one touchdown. Next half an hour, you can get somebody else to ask it.
Hey, if it in the growth. You know what?
So this please, you'll understand the difference between general solution and particular solution, right? This is a general solution. This is the general solution for that. If I ask for a particular solution, I need to find the value for C, right? I need to find the value for C. So I'll give you X and Y value. Plug in X, plug in Y, and then solve for C. That now becomes a particular solution, right? General solution, that's what you have there. Try this, please. Right? But I want you to go all the way and make Y the subject of the formula. Right? Go all the way and make Y the subject. So I'll give you an easy one. Since the first time. Separated variable. That right? Bring the Y on one side, bring the other. You'll get what I show you there. But you got off one on X. That's all. Why? Right, let's bring you Y on one side. Right, make Y the subject, all right? Make Y the subject. Right? So instead of move Y across here or divide both sides by Y. So if I divide by Y, I'll get 1 on Y dy, and then I'll get 1 on X dx. Okay? That's almost if you'll stick right there, right? But you had to move it here, right?
And be the log of Y is equal to log of X.
Right? And then you have to integrate it, right? After you integrate it, I want you to make after you integrate.
Hey,
One over. Right? What you'll get here? What you'll get here? Ln y is equal to ln x plus c. But I would like you to make y the subset, right? Right, so you'll get y is equal to, when you move ln across, what you'll get? Right, so you'll get e to the ln x plus c. Right, but here's what I'm interested in. Watch this here. This is the part I was interested in. E ln x multiplied, plus means what? Multiplied, right? E to the c. E ln is what? E ln x is x. Right? E ln x is just x. Right? And this here, I could just call that constant e. So you can write the answer like this. Yeah. Right? Where e is equal to e to the c. That's okay? The reason I give you this is if you look at one of the years, they ask you to do the same thing. Right? They give you an exponential function and you have to solve it. Let's go again.
This is our question, right? E ln to the 1 will be 1. So, like I actually
Integrate there. Integrate it. Yeah, you had to find some solution. So Right, what's your use? What's your use here?
So until you ax plus b to the power n plus 1 over n plus 1 by 8.
What do you got, John? What do you got, John?
Yeah, just have a sort of fix it in brackets. You equal question, and then you make an example of the formula.
Right? Only one letter missing, use. Right? So the question said use an appropriate substitution. Right? So they didn't want to use that, right? So du dx is equal to 1. So du1 dx is the same thing. So you'll get the integral of u to the power of a third dot du. So you'll get what's that 413 over 413 plus c. So your final answer will be 3/4 x plus 1 over 2. Use an appropriate substitution. Right? To work it out. Alright, let's go again. Next one. This is 2008. Right now, sorry, the quality is not even best. It's 2008. Right, do the start from here. Do the integration and then do the differential equation. Right? Let's pretend it's x squared plus x all over x to the 4th. Looking like that actually. X to the 4th, yeah. Looking like x to the 4th. Integrate that first and then do the differential equation. Yeah, x to the 4th. I do this right before you do it. Then you want to make the differential equation. So yeah, let's simplify it out, right? Divide everything by x equal. Right?
Oh, yeah.
Just tell me like a normal thing one, X squared on X to the fourth. Alright, so I seen a little mistake with some people here simplifying this, right? Right, I just seen a little mistake here and some people not simplifying it properly, right? X squared plus X minus 1 all over X to the fourth. What this here implies is that X squared is divided by this. X is divided by this. And minus 1 is divided by this. Right? That's what it's actually saying. These two are the same thing. Right? So now, if I simplify this, what will I get? X to the minus 2. What will I get here? X to the minus 3. And what will I get here? Right? Now it should be simple to integrate. Right? They say integrate this, so you have to just divide it up. And what are you going to do after? Right? So some people say this, right? Some people say it, right? Some people were trying to do this. Nothing wrong with that, but when you bring up X to the fourth, you'll get X to the minus 4, right? Right. And then you have to multiply each one. Right? Which is the same thing. Okay? Then you're going to multiply this by each of the values. Oh yeah. Try it quick. Oh yeah. Right, so what you all got here? Right, what you all got here, all we have to do is add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power. And that's it. We get x to the minus 1 minus x to the minus 2 and 2 plus x to the minus 3 and 3.
Minus X.
Huh? Oh yeah, minus x. Right? You want to make it look a little fancy, get them back like this. So that's minus 1 on x. This one here is what? Minus what? How I can rewrite this? 1 over 2x squared. And how I can rewrite this? 1 over 3x cubed. Right? So your final answer will look like that. Right? Oh. The next question. Oh yeah. Go again. The next one. Right? So I'm moving the dx here. That's okay, right? You want to move the y now, right? So to get rid of the y, and I can divide everything else by y. So if I divide y on x by y, if I divide by y, right? No, it wasn't for you to see. That's what I'm doing. Oh, you only want to see it too? You want to see it too?
Yeah.
Well, say that you're not talk voice now. Can I see it too, please? A little manners, yeah? Right. Right. So if I divide this by y, I'll get y on x. And the y will cancel, I'll get 1 on x, right? So if I divide everything by y, I will get 1 on y dy is 1 on x here. Yeah? You sure? Right? Right. Going back to this one now. Right? Going back to this one now. Sorry. You need to develop the differential equation, right? So help me out now here. What's the equation? The volume of a liquid, so they give you V. The liquid leaks from a container at a rate of, right, at a rate of 30 centimeters per second. So what will be your differential equation there? Rate, right? What is changing? the volume, right? So this 30T represents what? Change in volume with respect to time. So that is our dV dt. That's it. That's your differential equation. The differential equation is dV dt is 30T. Are you okay with that? How we getting part 2 now? How you getting part 2 now? Find the volume of the liquid lost in the third second. Sorry. Find the amount of the liquid. So what are you asking here for? Yeah, if this is the amount of liquid. Right, so they want this volume. Right? Oh wait, I made a mistake in the first one. What's the mistake? Read it back. Made a small mistake. Made a small mistake. The liquid leaks from the container at the read. And I underline the mistake and I didn't include it. Negative. Right? I left out the negative sign. Right? Because it decreases. Right? So they want the volume when T is 3. What do I have to do? What do I have to do, Kiran? You have dV dt. How are you going to get V when T is 3? What do you do? Integrate. Right. So you solve the differential. Okay? And what technique are you going to use? What technique are you going to use there? Separation of variables. Go ahead. Separate the variables, solve the V, let's do it again. Right? Separating variables and solve it. Let's do it again. Why not leave C as 0? But it's not true because when P is 0, it contains a full. Yeah, you didn't give me any input to find C. That was the first step, so that's what we have. Right? So when you move across here, so leave out C for now, right? Leave out C. I think they make a mistake. Right, leave out C. Right? They didn't give you the input to find C. Normally they might have told you the initial volume. So when C is 0, you know why it's B and it's find to C. Right? Carry it across and you will end up with carry it across and you will end up with dV is equal to minus 30T dt. When you integrate, you'll get V is equal to minus 30T squared all over 2. Right? Forget the plus C because it didn't give us the initial volume. And then plug in plug in T as 3. Plug in T as 3. Yes. Oh, sorry, and the minus 9. Right, so here you will get what does the minus indicate? Any volume, guys. That's what you do. No, the V, the V, right? It's right. That is a guy. But you see and Allen, right, let's go again. Next one. What you all got when T is 3? Minus 1. Let's go again. Let's do the next one like this. That was 2008, right? Okay, the one you see already. Okay, value. Sorry, let me just say I thought about it. I'm gonna get value to try this one here. This is 20. Try this one is 2019 or 20 or something. One of them. No, this is yours. This is one of yours. This is one that came a few years ago. 2020. Try it. Try it. Right down. Now look it up. I want to see why you're top. It's pretty good one. I want like just before you break.
Yeah.
Like this, no.
If you look at
Take a time to develop this equation. When this is slope, what do you mean? Which is y, yes, right? That's all everyone can see. Even one, it's not.
question. It'll be so. Yeah, one question. So we need X of y and square of y.
This x equal to the product of the x by 1 on 1. Yeah, there's no one that's one that's oh wait. Huh? You did one. I didn't hear anything. Yeah, sure. Right, so by now you should have the equation. Right, they said that the slope dy dx. Right, that's the slope, right? The slope is equal to the product of x by the reciprocal of y. Right? How do we solve things like this? Separate the variables, right? So when you separate the variables, you'll end up with y dot dy is equal to x dot dx. Right? Then do your thing real fast. Right? They gave you info later on to find CS, so hurry up. Everybody getting through? You got what getting through? Wait, Adelia? Yes. Marquis, Dylan, Alia, Seth, Amber, Vinesh, Jacob, Faith, Amber again. Vinesh again. Yash again. Alia again. Marquis again. No, some name, the list have name twice. Dylan again. Seth again, right? Now we Shana. Javed, Jacob, Christopher, Esther, Samarika, Kiran, Jaden, Rahai, GRDN, Jaden. No. Ethan, or Ethan says Ethan. Jaden, Sydney, Darian, Jidan, Khan. If we didn't hear any name, we didn't remember this one. I said feed now. I didn't have any name. Right, so you end up with what? You end up with y squared over 2 plus, sorry. y squared over 2 equal to x squared over 2 plus c. Right? And then square and then multiply everything by 2. Right. But they want hence or otherwise. Hence or otherwise find the equation curve. So what do you do now, Aaron? What do you do now? Aaron, what do you do now? Aaron said to sub x is 1 and y is 3. And then solve the c. Okay, good job, Aaron. So that's 9 over 2 is 1 over 2 plus c. I got c to be 4. Anybody else got that? Nice. And you're done. You'll get y squared on 2 is equal to x squared on 2 plus 4. Let's go again. Next one. That's 30 copy machine at also.
What do you want?
If it's not there, I want to bring it up here.
Wait. It should be like last time.
Around this.
Because the last time is terrible.
Yeah.
Alright,
So good yesterday. So good day before. Nobody complained.
So, go on,
That's brand new copy.
I'm sure na, because after I see a pie.
Let's go again. Huh? I don't want to get all the meat. I think give it to Chelsea, right? Chelsea. What's the name? Yeah. Two other, right?
Sorry.
Up. Left in the arm, you know, that's last one like this. Last one. Oh yeah, please. Oh yeah, that's great. That's 2019. 17. Separating variables, go to now.
It's all right, all right.
Right, separating variables there. Right, so when it's separating variables, right, when it's separated, it might look like this. Anybody got this? 1 on V dV minus 1 on 2.5 and then integrate and integrate. Anybody did that? Right, now integrate it and then solve for C. Yeah, because they want B in terms of C. Right, what's the integral 1 on B?
Ln B.
Yeah. Right, ln B. What's the integral of minus 1 over 2.5? It will be minus 1 on 2.5 t. Correct? Right? Actually, you don't want to leave it as minus 1 on 2.5 because it's simplified, right? How much is that? 2 on 5? How much is 1 over 2.5? Right? And do you think when V is 25, and T is 0, solve the C. And then make V the subject, right? Don't leave it in terms of ln. Right? Try it quick. See what I did here? Oh, wait, now rub it off. Oh, you have to find for C and then make V the subject, right?
C will be ln plus 1 over.
Right, now, that's not correct. Where you got to C? That's it, neat. Where you got to C? You can see?
I get 3.2. I get 3.22.
3.22.
Yeah, 3.22.
Right? What's here to get the exact value, right? Ln v is equal to minus 1 on 2.5 t plus c. Right? If you want, you can make v the subject from now. It's up to you. Right? You can make v the subject from now. Like the one I was showing you here, but I rub it off. Or you could just plug it in here. V is 25, t is 0. This becomes 0. So you'll get ln 25 as c. No, you can leave it like that. Right? Because I'm waiting to make v the subject, right? So you'll get ln v, watch this here. Because I want you to be able to simplify it properly. Ln v is equal to 1 over 2.5. You all said it's 2/5, right? Plus ln 25. Are you okay with this? That's not us. Are you okay with this? Why yes? Right? I plug in 25, I plug in 0, and c is that. Right? And instead of writing 1 on 2.5, I just write 2/5. Same thing. Now you want to make v the subject. So v is equal to e to the minus 2.5t plus ln 25. What did I do here again last time? Right. So this is plus. So that's v 2/5 t multiplied by e ln 25. And e ln 25 is 25. So I can make this look nicer by writing 25 in front here. Right? So it looks a little bit nicer, right? Right? So I did not, you recognize I did not use the ln 25 value, right? I left it like that, right? I didn't round it off to 3 point something. Right? It wouldn't be wrong, but it wouldn't look, it wouldn't get a nice whole number here. Okay? So this is just like the one I showed you a little while ago, right? Let's do one more. Right? We'll be doing this here in full, right? This whole number set. Yeah. I don't know. Like a nice exponent conference. Right? It's a nice exponent function here, right? Sorry? So we start how was you won't take time. I went close to 5 past. Right, last one we do and then we switch to mod. If you want to start with C, go right ahead. That's what we're doing all the time. Right? Right, but we're doing A, B, and C. We're doing all of it and then we switch in. Huh? Oh yeah. Try that there. Right? Right. Again, if they didn't tell this substitution, you have to see it, right? See that? Passing buses, right? Take your time, make a substitution. That's the way to get. Right? You might recognize a slight problem here. When you make a substitution, x is still there. When that happens, you have to go back to the substitution and make x a substitute equal. Right? So most people got x u squared, right? We can't integrate that. So we had to get rid of the x. So we had to go back to the first substitution, which was u is 1 minus x, and make it up. And then substitute back. Yeah, correct. Or somebody make a mistake there, the integral is minus 1, right? Okay. And so a mistake somebody had just 1. Right. Oh, okay. If you come here, x is what? Okay. It's have a little feeling in your hand. Yeah, it had a feeling to do. Okay. Right? Next week, are you done? The whole thing, A, B, C, D. After this, it's trigs, right? But of course, as you would have seen, you will see how easy the trigs will come, right? How we integrate this, Amber? How we integrating this? How we can do? Because there's no product rule, right? So what to do? We just start to expand it out. That could work? Yeah? We can multiply it out and you'll get u squared minus u cubed. and now integrate it. Right? And now you can integrate. Wait, this is negative one, yes, sorry. Made a mistake here, that's negative one. Right, the UDX is minus one. Minus one. One minus x is one. Right, so what we got here? When you integrate this, you'll get u cube on 3 minus u to the 4th and 4 plus c, right? Or you can put the plus c in the bracket, it don't matter. Right, you'll get minus u cube on 3 plus u to the 4th and 4 plus c. U is 1 minus x, right? Right? Copy down. Let's go again. Part B. In part B, we'll be left hand side, then the right hand side, right? Right, ready? Next one. Right, help me out here. Like click on Esther. Esther, help me out here. So Esther, they want us to find the integral of the two of them. So what to do? Let's do the left hand side and then here. And then Shan will help us with the right hand side. Yes, Esther. What to write here? Right, and FT is what? 2 cos t 4 sine 5t. So what's the first thing you're doing here? Before that, what should get? Yeah, tell me what you'll get. So, no? Yeah, that's too. Yeah. So that'll be 5 cos t plus 4 sine 5t. And could we integrate this now? What's the integral of 5 cos t? Minus. And the integral of cos is what? Sine, not minus. So it will be 5. What about here? Minus. Something missing?
4 and 5.
Right. So it's, remember, you have to differentiate 5t, right? It's 1 over that. Okay? So it's 4 over the differential of that cos 5t. That's okay? That's the right hand side. Left hand side. Now for the right hand side, child. Right? So you have to find the integral of. Right? So that'll be 2 cos t. I just put the 2 outside, right? And here is what? Integral of 4 sine 5t plus 3 cos. What's the integral of this? 2 sine t. What's the integral of this? Cos 5t, right? And what's the integral of sorry, that should be minus. What's the integral of this? Nice. When you add it, what you get?
5.
Same thing. Right? Right? So you just do it separately. Right? Copy it down. Let's go. C, I will pick on pick another already. I'll pick any again. I'm already. Right? Copy it down. Let's go to C. Brandon, you help me C.
Brandon.
Delon. So Delon, they want us to get the volume rotated. I want to sketch that because I'm not seeing that too good. I want to do a little sketch, right? What does the sine graph look like? Nice. What the range they asking for? Pi, that's not range.
0 and 5.
0 and pi, no.
Oh, no.
What's the range good?
Pi on 2,
Right.
pi.
So they are interested in pi on 2 and pi. So they're talking about rotating that area there. Right? Right. So if you rotate up, and what they're talking about y is 0. What is that? Right. That's the axis. So they want this region here. You're seeing that? Between pi on 2 and pi, they want, and this region, they want to rotate that shaded region. Okay? So what's the volume? What's the formula? Remember the formula? What you do, Ran? I got to play example. Right? Pi by what? The integral of pi over pi In this case, f of x is what?
Y squared once.
In this case is what? Sine x squared dot dx. Right? Now you had to figure out how to integrate sine squared. Okay, we're taking the formula
Just do f of x squared.
of x squared. Whatever the function. Right? Go ahead, integrate that. You're working in degrees or radians?
It's really understood.
Go ahead.
This is nice, but.
And part D will go to perfect.
Nice, very nice.
You can time and integrate.
What's the fire? Before other people.
I have tiny integration there. Right, so please don't integrate sine squared and right cross. Now I'm going to show you otherwise. Right? What do we do again? Use the identity sine squared. Okay? Check back the formula sheet. Check back the formula sheet, right? We use this. Right? We use cos 2x is 1 minus 2. If you rearrange this, you'll get sine squared x to be a half minus a half cos 2x. This is what you're going to integrate, right? You can't integrate that using the formulas, right? Right? They want you to use the identity to integrate it. Thank you. Good. If you want to water the ramen downstairs, right? Maybe next week I'll run it. But you gotta come to it. Next week. Yeah, I put sugar out everything. You understand this, I think I'll finish it. It's a sugar and milk.
This 12 o'clock, we are not great.
No, sir.
Well,
After 12? Oh.
Yeah, let's put it on.
No, no, take it into it now. You can integrate now. The integral of a half is a half x. The integral of a half cos x is 1/4. Right, so you can integrate integral of a half is this. Integral of this is 1/, the differential here to give you 4 sine 2x. Right, so I just integrate and then plug in the pi and the pi on 2. And you just tell me what you get now in terms of pi. And what again? I get pi squared on 4. Plug in the answers and see, right? Plug in your pi on 2 and see what you get.
And sine of 5. Oh, okay.
Right, but you just put this in the calculator. Put pi in here, work it out. Put pi on 2 on here and work it out. Right, to the last part D. Are you okay with this? Right, so if you remember this right earlier, if you get squared or cube or anything, you can't integrate it directly. You have to use an identity and then simplify it out. Okay? I don't know, I just plug it in my head and work it out. Put it in the calculator now. How much you get? Just plug in pi, see what you get. Plug in pi on 2 and see what you get. What you get? And you multiply the pi on the outside. Multiply squared on 4. How much you get, Ash? Oh, you mean you'll try and integrate this? Right. I'll do it for you. Watch. So a half costs 2x, right? Right? You can leave the half outside, right? What's the integral of cos? Right? And it's 1 over the differential of 2x, which is and then sorry. That's the rule. That's the rule. If you want to prove it, make a substitution and you'll see. Like let u equal to 2x and you will see it always 1 over. Right? So all here. Remember, if you have to integrate cos ax plus b, if you have to integrate it, it's 1 over the differential by the integral of cos, and then you put back the brackets. That's okay? That's what you meant. And then you plug in the values up.
So I was saying,
Like not serious, but once they start like that, not serious.
Like, X plus.
Right, to the next one, to do indeeds. I think I picked somebody already, that's not. Yeah. But you someone from that. Yeah. Next one. How we do that again? Right. Right? How we solving part the scanner? How we doing that? The differential, so I have to do. But technically we use the earlier. Separated variables. But be careful with the right hand. Be careful with the integral of the x part, right? Right, if I'm done with it right here already. Yeah, very good. Right, so the integral. And try to take the integral sign of the integral, right? So I'm just going ahead. Trigs after, right? So the first part of this exercise, you're coming on the board and writing out all the trig rules. All the identities, yeah? Right? You can put somebody from your row coming and do it. So you can nominate somebody in your row. You just have tuition on the right side, right? They give you values to find C, right, Julia? So find C. Right, so this was the answer for part A, this was part B here, and this was part C. Right? Think coming on the board here and do part B, right?
Yeah.
Who wants to do it? Anyone want to do it?
Yeah, I'll do it.
You're right, Nick? Who wants to come and do part D? Huh? Wash your hand. Wash your hand.
So let me do it now.
I don't know.
Let me do it.
You don't want to do it? Come on. You got it right, Nick, huh? You ain't have pen, I'll give them up.
I don't want to be recorded. I don't know if I do the active this. What? I don't know if I do the active this. Which way?
Right, but boy, I take you off one time, that's no long. That's square. Without like that. Full function, like. Plus one, it's all to the hundred.
I don't like separate.
Put it into go.
Oh, right.
Oh, wait, the Castillo one, like. Right, next, that's on Trig rules. Yeah.
Yes.
Oh, I know. So you
But they are like, yes, oh, yes. They get our, you, yes, or.
Oh, yeah, that's right. You have to look that up.
Right? So this is the end of it.
It's not by and
This one of the two, this one is the one, right? And every new one there.
let's make it one thing. So how we can go off.
Wait, and this will be on the search?
You can probably have. Repeat that, you done? Y'all got that?
I'm not saying.
And it'll be two.
No, but.
No, you guys are all like. And then you're gonna find C. You're gonna find C, yeah?
Well, that is why
Right, no, just plug in the values. All right. What were the values again? What were the values? 0, 1. All right, just plug in X and 0 and Y. Anybody got up? Anybody got up to C? 2 minus a third? Not correct, right? C is 513. 513. Anybody get up? 513? No? Nothing earlier. Yeah, I'm right. All 5, it's always like what the 5 word. True. Right, so right, I know the angle here a little bad, but we separated variables, we integrate the left side, we got y squared on 2, the right side is this, right? The right side is this, we use a substitution method and we replace for u. When you integrate, you got u3 on 2 and 3 on 2, 2 cancel, you get 1/3 u to the 3 on 2, and you put back u and then you plug in. And then you plug in y is 2 and x was 0. And we got C to be 5 and 3. So your final answer is y squared on 2 is equal to 1/3 by right. If you want, you can multiply it out and then square root it, right? Question said y in terms of x. It said y in terms of x, so I just set this out for C. Okay. Right, integration time. I mean, 6 times. Yeah. So, right, because by now we should know your rules, hopefully.
Hey, Samar, discuss. Marcus. Yeah, we had a big I just wrote that everybody said it was smart.
Plug in, let's go.
Yes.
Ready, let's go. Anybody else? And then Trigs, that was that Trigs.
This one money. Wait,
Evolution now. Oh, you'll join up.
Yeah.
Oh. Somebody not answering.
Oh.
Type the answer.
No.
No spaces, lowercase, right? Whatever number 2. There's no spaces, right? No spaces. Let me just put number.
So what do you want to get? You like
A green is identical.
yeah.
Oh.
My God. Any quiz ID, any quiz ID, any quiz ID.
Watching your own.
Oh God.
Yeah, when they stay back to office.
Oh my God.
I got it.
No, I thought
Another mistake. I should be side plus side.
Sir, this
That should be sine A plus sine.
I don't care.
What was that?
Right side. Oh. Okay.
Gotta write that down and work it out. Hey, okay, right here, just hide the answer. You said it. And expand on it, top 175. Right, so you have to expand on it, top 175. I just guessing.
Oh,
Right, cause because the expansion here is negative, right?
I mean, is it? I mean, 60. Right there, I see it there.
Right. That's right now, right?
Yes. Yes. I know. I know. I'm so stupid. That's not fair. It's 6th place. I'm supposed to be in 5th.
What is that? Right, so one of the problems is that we don't know the rules, right? Right, just take a break and 1 o'clock we start back and we do Trig. And then that's it. Right. They want you this now. I want that change for that is what? Module 1, 2, or 3. Module 1, 2, or 3. Right, so we got this questions like this, right? Right, so we're gonna do a couple of questions like this, and then we'll use the other rules, right? Right, what's here?
Yes, sir.
Right, we started some right here, right? We'll just do some of those because those are the see them almost every year, right? So check the whole question, order number 3. Right, so we need to remember this, right? Questions will ask us to put in these forms, right? Right, so after they put it in this form, we know to get R. R is the square root of a squared plus b squared, right? So you have to know when to choose, the particular one based on what they give you, right? Based on what they give you. Right? If they give you this here, if they give you this is the expansion you're using. And to get R, you square these two and square root it, right? Or you get alpha though. Right, that's one way. The next way is to expand and compare coefficients and solve. Right? So this is only if they don't tell you which one, right? If you see a plus on sign first, you're using this. Right? If you see a plus and then the cos first, you're using this version. If you have a minus, right? And always remember your max value is always what? Your max value is R if it's in this form. If it's in this form, it's R. And your min value. Right? And if you could find your max and min value, you could find the max and min theta as well, right? So it's the same kind of thing that you will see all the time, right? Huh? Yeah, if you give you a different form. So let's try this one from 2017 here. Right. So they want to get a general solution here, right? So what's here? They wanted to solve, but it didn't give you anything. So which one you'll choose? Which form you're going to write this in? right? Because it costs first, you can use this one. It don't matter which one, right? You can use any one, right? You can use any one. And it's the best one to use if they don't give you, right? So solve this, put it in this form, and then solve that equation. Mistake I would do it, I'll give it another try. This one is 17. Right, this is 2017, right? Try that way. That one. I just 2017. That's how I'll give it some time, right? Right, you're almost guaranteed to see one like this.
Very cool for my planes, sir. So, you know,
Just finish. Start 1 o'clock and finish.
Oh, sure.
Right?
okay, then you get the money.
So you should have R by now, right? R is the square root of 6 squared plus 8 squared, which is 10. Right? For those who missed it, if they don't give you what form to put it in, these are some rules that you could use here. Right? If it costs first and it's a plus, using this. Right? So we are going to use R, right? Plus and then cos first. We're going to use R cos theta minus alpha. So we're gonna take this and write it like this. Right? So when you expand this, you'll get r cos theta, cos alpha, minus, sorry, plus r sine theta, sine alpha. When you expand, you're getting this. So well, when I compare this to this, I'll write it underneath right here for you. Right? I'm going to compare, right? When I compare 6 cos theta and 8 sine theta, what does r cos alpha give you? R cos alpha is 6. That's okay? And then you will see r sine alpha is 8. Right? Are you okay with that? It's just comparing. So now you have r cos alpha is 6. If you want, you can find for sine and use the tan, right? But I using this right here. I'll give you the same answer. Alpha is cos inverse 6 over r, which is 10. How much y'all got there? What y'all got in calculator? No, degrees. Put it in degrees. This one was in degrees. This one was in degrees. 53 point. Right? So now we know f of theta. Now we know f of theta is 10 cos theta minus 53.1. Right? So all I did, and these questions come the same way all the time. All I did is I took this and I put it in this form and it looks like this. That's okay? The last part, they wanted to solve this. So what to do? Right? Make this equal to 2. But what they want? So you're using a general solution, right? No. Yeah, you need the alpha in general solution. Right? So look back at the general solution. So once I gave you, and let's see what you end up with, right? Right, let's look at the general solution. Yeah, why you all want to watch it on the answer? Right? Look at the summary, first page is general solution. Right? What's the general solution for cos theta equal to k? Theta is equal to 2, right? Plus and minus alpha. And alpha is what? Alpha is cos inverse k, right? Yeah, cos inverse of that. Okay, so this here is your theta. This here is your theta. And right, so your theta will be theta minus 53.1. And then you find cos inverse of characters 10, 2 over 10. Right? That is your alpha value. Right? So your general solution. Well, look at each general solution. You gotta learn this. They don't give you this, right? You have to learn general solution. So the general solution is theta. In our case, is theta minus 53.1 is equal to 2n pi plus and minus alpha. Alpha is cos inverse of this. How much is that? Cos inverse 2 times 3 degrees. How much? 17.5. It's a general solution.
if it's like possibilities, right? But it's like
They won't ask for that, they will ask for a general solution. So it'll always be in terms of huh?
70.
Oh, 78.5. Right? So that will be 78.5. When you move across this minus, it becomes plus 53.1. Okay. Remember this plus and minus, huh? So it's two versions, plus this and minus. Right? So those will be general solutions. Yeah. You wouldn't get like no, sir, no. T is just between 0 and 90. Right? Alpha is just between 0 and 90. Right? So this general solution here, the alpha is always the when you make theta the subject, cos inverse of that. Right? That's the alpha. This is the theta, and you can move across the 53.1 alpha. That's okay? Let's go again. Next one. What's the maximum value of f theta? What's the largest value f theta could be? Right? So the maximum value of f of theta is r, which is 10. Let me root it there for you again. And what's the minimum value?
-10.
Minus 10. So question, Yash. Suppose I said, find the value of f of theta equal to 20. Suppose I said f of theta is equal to 20. Huh? Right? No solution, right? So there was a question or a multiple choice where they ask you, can you solve for f of theta equal to something? Right? And that's how you figure it out. Your max value is 10. So you can't solve anything bigger than 10. That's okay, Olia? Let's go again. Next one. Right, this one. Got there. What does it two theta mean? Does it change anything?
And the other ones are
No, nothing to do with
something.
right. So instead of the kind question,
Oh, the range.
right? The kind question, right? Instead of it being normal theta, what they have there, right? So nothing really changed. The same thing, right? You're doing the same thing. The two theta that indicates that it working in terms of two theta, right? Right side up, let's go again. One here after one. One answer.
It really is not.
Oh yeah, that's right. Right, follow it through and then find the value on it, right? Right, all yeah. I know most of y'all used to using tan. You go ahead and use tan, right? Right? Those who do that, it's a tough time, come on. Pay attention to alpha and what? Yeah, not right. Calculate open school for the line going on.
What?
Checking your hand on that.
Yes, it is because you're switching. Nah. Tell them. You'll bring up backup calculator. Tell them. I don't know.
Right, so when you expand it out, I got R cos alpha to be 3. So alpha cos inverse 3 on 5. In radians, how much is that? 0.927. Right, and so now f of 2 theta is equal to 5 sine 2 theta plus 0.927. Right? After that, they want the max and min values of this. They want the max and min values of this. Right? Oh, yeah. I'm not sure if you remember this rule, but if f of 2 theta is this, f of theta is simply just divide all the angles by 2. All the angles. F of 3 theta will be, well, f of 4 theta will be multiply all by 2. Right? So it will still be the same function, and it will still carry what's the maximum value of f of theta?
Minus 5. Really 5.
Will be 5, and what's the minimum value of f of theta?
Minus 5.
Right? Now they want the max and min values of this.
So it'll be 1 over 2.
So it will be 1 over 7 minus 5, that's 1 over 2. That's your max value. And 7 minus the minimum value. That'll be 1 over 12. That is your minimum value. That's okay? So you're taking these values and putting it in there. What's Amber? How what? How I get it 3 over 5? Because I compare this to this. So ignore that. If I scratch off sine 2 theta, and I will get r cos alpha 3. Right? And r is 5. So I carry across the 5 and find cos inverse. Right? This is one way to do it. The next way is to find cos, find sine, and then divide them and find tan. Same thing.
Since you have f theta, right?
Yeah.
You're not like in theta.
No. What I was now saying is that f2 theta and f theta, all that would change is the angle, so it won't change our.
If they actually general sort of thing like that, they have to like a theta go.
Yeah, I had to change it a little bit. But it was, that was an error in the year. It was supposed to be 2 theta. Here.
Yes.
Was an error. You're okay with it? Right? So questions come just like this, right? Remember I told you, right? Like the last one, if they do not give you, you have to recognize that you have to use one of these, right? If they give you 3 cos theta minus 5 sin theta equals to 4 until you solve it, you have to recognize that you have to convert it and then solve it. Okay? General solution, well, yeah, you have to learn all the formulas, right? Let's change it up now. Let's do some identities. Right? So pull out your little sheet with the identities, because I don't know if you know all of that. So how much time and hours you have to know them. Right? And we're gonna try some. I'll start that you do one, then give you a hard one, right? Let's start easy, right? It's an easy. Sorry, that's not easy. But you guys go hard 1 second, right? I don't know. Thank you very much.
Yeah, direct.
Yes,
So, say, plus, plus 20, plus minus 20. What? This check my items.
you're welcome. You are welcome. Right, which side you work with here? Right side. Right, there was 2 lines long. 1 plus tan squared is what? Right? 1 plus tan squared is sec squared. So you finish. Right? 2 lines again and you get it. Try it quick. Look at you. Look at it. Sydney guys. No. Sydney. How far you reach? Halfway. That's a good sign. You know you reach halfway. Half again to go. Right, so you should recognize that you have 2 tan theta divided by sec squared. What again? 1 over cos squared. Right? Tan is what? Tan is sine theta over cos theta. Don't forget the 2 on the outside, right? Right? And then the division becomes what? What happened now? Cancel the cos, right? Now you have 2 sine theta cos theta, which is right? That's all. Yeah, trouble. Samson. Trouble. Yes. So they go again. Next one.
Explain your final. He's saying to be divided. Sine.
All of them.
Is the
All equivalent. Let's go back.
And they have a meaning.
Which one?
Yeah. And it's how I the information. The down big
Let's go again. Next one. That was easy, right? Let's go a little bit harder. Right. Which side do you work with? Left or right? Which one?
Left.
Left? Left? All right. Yeah, left. Yeah. I'm gonna do it from whichever one you do. You pick one out there. You pick one side and I'll. The next one there, ma'am. And also remember this rule here that you all keep forgetting, right? Right? If you have something like this, let's say you have x plus x squared over x cubed plus x, right? If you have a fraction like that, you are allowed to divide every single thing by the same value, right? So if I divide everything by x, right? No, the fraction will change. Technically, what you're doing here is multiplying by x on x, which is 1. Right? So remember that because they might need it when simplifying. So you want to find the LCM and then the LCM on that. The LCM on that. Right? Each time, expand the cloud. Use the left side, just expand the right side one line. Right? If you want to get probably. Anybody else get?
Yes.
Okay.
Leave me alone. Nobody's there. I cannot see. Yeah, it's not.
Okay. Last time. Just not on it.
Lucas.
I don't want.
It's not.
What?
I knew.
That's right. But when you get a equal, just take this and right, I have two fractions here to find the LCM. Right? When you find the LCM here, you'll get cos y sine x minus cos x sine y. That's when you find the LCM here, right? And here, when I find the LCM here, I'll get cos x sine y plus cos y sine x. What happens when I flip it over? Cancel over. So you'll end up with cos y sine x minus multiply by, I'm flipping this over, right? Right? This will cancel. This will cancel. And we know that this here is what? That is cos x plus y. And here is cos x minus y. I was just checking to see if anybody recognizes. That's what it's up on. That's what it's up on. That's what it's up. There you go again. Same thing. Backwards. So right hand side is you write this, right? And then when you write this, what you might not see is that you have to divide that here. So you have this, and you have to multiply it by this over this. And then you have so you have this, right? This over this. So you're multiplying it by this over this. That's one way you can do it. And next way you can do it is that each one of these terms you multiply by sine x sine y. Each one of the terms Each one, so you divided each one of them. So you will have cos y sin x minus whatever, right? You're dividing it by this. That will cancel and you'll get cos. Right? So you're taking your fraction and divided every single one by sin y sin. Last one. Right? We have solved it.
Why do we not do
Right up, next one. Prove it and solve it. Right, who are the pair this pass now, right?
Yo, shut up, shut up, shut up, shut up, shut up, shut up, shut up.
What's the name again?
Yeah, I'm just surviving. Yeah. Yes. I think it's all very.
Right, so once we can solve, that's it for trigs, right? Let's see if we can solve. What I got really? What I got really too?
Yeah.
Because easy.
Yeah.
Right, so I'll look to the right hand side. Course that is one on sine. Hey, good one.
Yeah.
Right, here's an example of here's an example of I'm going to multiply every single term by sine theta. Right? I'm going to multiply every single term by sine theta. So you'll get 1 over 1 minus sine squared, which is 1 over cos squared, which is sec squared. Right? Right? Next, how do we solve this now? How do we solve here? What to do?
Triangle 9
It's a hence, right? So what are equal to?
forward.
No. What are the parting bracket equal to here, right? Huh? Right. Well, the parting bracket here is sec squared, right? We just prove it. So it means that sec squared is what? So it means that sec squared is 1 and cos squared is equal to 4 and 3. What to do now? Cyan? Cyan, what to do now? Well, whichever one, yeah. Whichever one down. Huh? Sean? Right, Sean, talk about now. What to do? Okay, well, I'll read the second part tomorrow. What we can do? So we already replaced this with sec squared. And sec squared is 1 and cos squared. How we can solve that? Right, remember you're always trying to make theta be something, right? So the first thing you can do is what?
Both sides.
Before that, can you cross multiply? Can you cross multiply and get 4 cos squared theta is 3? And then what you can do with it 4? Bring it across. Cos squared is 3 over 4. Now you can what? Now you can square root both sides. So you're going to get cos theta is plus and minus root 3 on 2. So you have to do it twice, right? Sorry? No, that's theta. Huh? No, you have to go and find it. Right? So you have to go and find theta is equal to you have to find theta is equal to you have to find theta is equal to cos inverse root 3 on 2. And then do it to the minus as well. Cos inverse root 3 on 2 is what? 30 and no, where is cos positive again? Remember positive, right? So you have to find all the angles where cos is positive. So that's the first quadrant and the fourth. So that will be 360 minus 30, which is right. What about the negative part now? Where is cos negative?
Somebody asking things are really
Oh, sure. Well, we'll fix it tomorrow, right? Right, yeah, in terms of it, but let's fix it tomorrow, right? Actually, no, that's the theta. But not the cos theta. So cos inverse is what's that? 5 on 6? And the next one is what? 5 pi on 6 or 11 pi on 6? 11 pi on 6. Right? Where is cos negative again? In the second and the third, right? Yeah. So that'll be pi minus pi on 6. So that'll be 5 pi on 6. And the last value is what? Pi plus pi on 6, which is 7 pi on 6. Okay? And that's the way we solve, right? Any questions? How to solve? I'm nice. We'll give it up. Sure. Right, that's Shanna, you okay with that? Sure. Right, next, let's move on to vectors and geometry. I can leave out geometry. Yeah. About vectors. Oh, that's one sheet theory. You already have one question. Oh, what's here, right? Pardon me? Leave out logic and reasoning. Oh, are we doing module 1? I thought we were leaving out module 1. Right, ready? Oh, I just doing about something here, right? So we got cos theta is equal to plus and minus root 3 and 2. Right? Watch here. Right? So watch here. So you had to work it out, right? Theta is cos inverse positive root 3 and 2. And theta is cos inverse negative root 3 and 2. So cos inverse root 3 and 2, we got pi on 6. And 2 pi minus pi on 6. First and fourth quadrant, right? Right? Now, the negative is where? In the second and the third quadrant. So, how do I get in the second quadrant? Pi minus pi on 6. And pi plus pi on 6. Right? So, my 4 values are these. Right? If this is a general solution, then you're going to use that. Okay? Yeah? Pardon me, sir? There's alpha here, sir. There's alpha and you put it in there, sir. Okay, sir? Yes, sir. Anything else? Right? You gotta learn that, right? You have to learn the general formula and you have to learn the factor formula. I'm sure you still get the formula. Right? But if you have the new formula in school, they'll get I don't know what version they have. Apply the one already. Apply one already. Apply the goal there. All right, so next, let's take a look at geometry. Right, so we have one questions on the circle and on the ellipse and the parabola, but we will do some Locus type questions, right? Locus is the hardest thing in that module, in that part. And then the vectors will be kind of nice. Yes. All right, let's go. There's something to remember. Right? There's something to remember. You don't really have to learn the definition of a loop. You have to learn the definition of a loop, right? Right? But you have to be able to identify if this is equidistant from a fixed point, it will take us a circle. Right? It's nice when you can take the info and you already know what the locus is. Right? For those who don't know what a locus, first time in your life, imagine you have a point and you give it some conditions. And you allow the point to move based on those conditions. Right? The point will trace out a path. That path is called the locus. All right? So the locus, so a circle is the locus of point which moves in a plane so that it's always equidistant from a fixed point. Right? And I'll show you in a little while how to figure out all of them. Right? A circle, you have the equation of a circle there, you have two forms, and you have the general form down there. All right. I know you all have different letters, right? Some people know it like this, right? Some people know it like this. X squared plus y squared plus 2fx plus 2gy plus c is 0. Same thing, right? Find f and g again, center and radius. Nice. If you look here, this might be a little bit new.
It'll be negative f and negative g.
Negative f and negative g. Right? Parametric, right? So if you look here, those are the equations for the parametric of a circle. How you do from parametric to the Cartesian again?
Science will take up.
Right? You make sine theta the subject, cos theta the subject, and put it into sine square plus cos square. Okay? So you take cos and sine and you put it inside that. Right? So that is your parametric per circle. Right? For you to find the equation tangent, they give you the formula here to find the equation tangent. The long method is what? What's the long method to find the equation tangent? To find the equation of the radius, then negative reciprocal, then plug it into the y is x plus. Okay? It could be a bad circle. All right. What would happen, right? What would happen if I give it 3 points on the circle? Don't give it the center and don't give it the radius. How you'll get the equation of the circle? If I give it 3 points on the circle. Right. What you can do is substitute it and then solve the 3 equations simultaneously. All right. Yeah, kind of low. That's okay. Then we have ellipse, right? That's the locus of an ellipse. Here's the equation of an ellipse to the center 0, 0. And here's the general form to the equation of an ellipse. Right, I've said already, I have more questions on it, right? Right, an ellipse looks like this. Let's just talk about this ellipse, right? This ellipse here is an elongated circle, right? And the minor axis is where? Minor axis is the y, and the major axis is the x. Right? F1 and F2 are what? Foci, right? So that's 2 special points around the circle. Around center, I mean. Right? And there's a formula to define it. Here, these are your parametrics. Anybody can recognize the difference between the parametric for circle and parabola. So in terms of what you see in there. In terms of what you see in there. Yeah, anybody recognize it? What's the difference? What's in there? I'm going back. What's in there?
So the R in front of the sine and cos.
The value in front of sine and cos is the same for circle. What it is?
Different for ellipse. Ellipse.
But it's different for ellipse. Right? Right, it's different for the ellipse, right? All right, nice. Parabola. These are your 2 types of parabola. X squared is 4ay, y squared is 4ay. Right? These are your parametrics. Right? These are your parametrics here. Right? These are your parametrics. How you do these though? How you take that parametric and get the equation of the parabola? What you have to do? What's in your box? What you have to do? How you going from here to the equation of the parabola? Have it? What you can do? No, no. Huh? Any ideas? Anybody besides Josh? And something is square, no, at all. Right, yeah. You can make T the subject. Make T the subject and put it in there. Do it now. Do it fast and see what magically happens. To go from parametric. Cartesian. Parametric to Cartesian. Second class and see what you get. By writing number, yes. You don't have to wait mathematically. Excuse children, you can share the scripts. You have my head, what's that? Right, quick. Huh? Yeah, make T the subject and plug it into X and see if it turns out to be a parabola. Yeah? It work out? Right? If I make T the subject here, I'll get T is equal to Y over 2E. And then if I take off T here, I'll get X is equal to A by Y over 2A squared. Right? When you square it up, you'll get X is equal to A on Y squared, 4A squared. Right? And then the 8 will cancel. I got Y squared to be 4AX. Right? That's a parabola. Right? That's a parabola. Sorry.
I'll be a silly. I got a silly.
Right? So that's the parabola and that's that, right? But what I want to focus on is how to find the locus. Right? So help me out here. Let me see who I am pick on. Cameron, I'm picking you for the night camp. Right? These are the same things that we did in the crash course, right? But right, what you see? Let's say I gave you a point, right? And the point is P. Right? Let's say I gave you a point P, right? And I said that the point P, right? The point P is 2 units away. The point P is 2 units away all the time. It's always 2 units away from 2, 3. Right? How do we find the locus that P will trace out? Right? P is always 2 units away from 2, 3. Most important thing in questions like this, you must have a diagram. Right? So how do I work out that locus now? So what I need to do here is find length of the line. So using the length of the line formula. What's the length of the line formula? With square root of x take away 2. Right? That's the formula there, right? Square root of x2 minus x1. Right, x2 here could be x, but I use it as x. x1 will be 2 squared, y minus 3 squared. Right? What's the distance here on from here to here? What's the distance? Right, distance is 2. What do I do now? Square both sides, and I'll end up with x minus 2 squared plus y minus 3 squared is 4. Or 2 squared. What this is? A circle with center. So positive 2, positive 3. Right? Positive 2, positive 3, and radius 2. That's okay? So we're doing questions in that diagram. Okay? Question. What's here? Kieran, suppose I said it was a distance d away, in fact 4. A distance 4 away from the x-axis. Anybody remember how to represent the x-axis? Right. The y value is always 0, but the x value changes. So to represent any point on the x-axis, it will be x0. Suppose it was on the y-axis. What would it be?
0y.
Suppose it was a horizontal line passing through 2. Y is 2. What will it be? Any point on the line, y is 2, right? And then the x value will be x. Suppose it was a vertical line passing through x and 3.
3y.
It will be 3y. All right? So it's important you know how to represent the line as one singular point. So you can use this formula. Right? Next one is for you. Right? Yeah, I'll put them goals. Right? Skybox C. Skybox C there, please. Diagram. Sky C. Yeah, we just have to what the last one? Yeah, but you have to get like hurry up. Wash, put out this time. Right? Go ahead. That's it on diagram. 13 there. Yeah, go ahead. Right, so what you got to do is find a way to represent what it tells you there, right? You can try to use it half. Then I use it half, use like D and 2. Right? That's possible what you got. You're right. Huh? Real what? Right? Do use x on 2. Use d and 2d. Oh. Oh, where Bradley? Bradley, ready? All right. Take it time there, Brad. It says 0, 0. What was the next point then, Bradley? And the x-axis. Right. Hurry up, plus some big points. Plus it up. You got to be exact. Once you write the end to the right. Oh yeah. Right, both sides are looking okay. Right, so the point here, the point xy is right here, right? They said it moves such that pxy moves such that the distance from the x-axis, right, is half the distance from here. So if here is d, here is 2d. Right? So now all you have to do is use the formulas, right? So 2d is equal to the square root of x minus 0, y minus 0 squared, and t is what? Square root of x minus x plus y minus 0. Right? And then you do your thing, substitute d and work it out. Right? Are you okay with that? Right, we done? So you putting it in here. So you'll end up with 2 by the square root. Remember, this is d, right? This is 0 and this is y squared is equal to this square root of x squared plus y squared. You can square both sides one time, or you can just square root y. Now you can square both sides. Remember to include the little 2 there. So you'll end up with 4y squared is equal to x squared plus y squared. Bring a y on this side, you'll get 3y squared is x squared. Yeah, run. Hmm? Run it back. No, I done it. Huh? Right, so what's it again? Allocated diagram. Right, now you have this one. Right, now you follow how we got 2D. 2D is x2 minus x1, y2 minus y. Right. Huh? Right, but you follow this and you follow this, right? Are we here? All right. I'm gonna simplify here for you first, right? There's the square root of x squared plus y squared. And this here is what? 0 plus y squared, right? And there's 0 and there's y squared. What square root of y squared is y, right?
Okay.
Right? So you might recognize that d is simply y.
Okay.
See that? So after I simplify this again, d is y. And I put y is here, I get 2y and I would square both sides. No, forget that. I do it here for you already.
Okay.
So then I put 2y and I square both sides and I would. Yeah.
Okay.
So I put d in here and I equate it. Randy, you could not forget the next one, please. Sorry, go ahead.
When you're getting the y squared, it's square root y squared.
D is equal to the square root of y squared. So I substitute d is the square root of y squared in here. So I get 2 by the square root of y squared is this. Then I square both sides. Let's go again. One more, and then we can change the vector. But we have vectors, so do we want what we want? All right. Vectors one time, we will take a small break. Like if we take 2 hot breaks, we'll go, we get a finish up everything in module 1. That's 6 hard parts, right? But then you can't get a break from that. All right. Take it half an hour now if you want. Right? After the break, we do vectors and we'll do vectors and what did we do? One is the hardest.
Hey, Napoleon.
PMI.
Napoleon.
What?
Napoleon.
Huh? Yes, like half an hour. Take it half an hour. Right, so we'll do vectors at 3 o'clock. Right, we start back at 3 o'clock. Alright, so three-dimensional vectors, right? Give x, y, and z value. How to add vectors? Add the x, add the y, add the z, right? Right. How do we find dot product? That might be the only new thing. Right? Dot product, remember we call it dot or scalar product, right? So basically you multiply the x values, multiply the y, multiply the g, and add them up. 4 plus 10 minus 6, and we will get 8. Right? So just a little reminder how to find the product of two vectors, right? What is called again? Product of two vectors is what? Right? Scalar product, right? Right. Quickly, it shows you how to find the a unit vector, the vector over its magnitude, and the angle between two vectors. Right? If two vectors are perpendicular, their dot product is 0. If two vectors are parallel, they are scalar multiples of each other, right? Basic stuff from mathematics. The only difference is in 3-dimensional. Right. What might be a little bit new now is that we need to be able to represent a line. Right? To represent a line, we need two things. We need right? We need a point on the line, and we need a vector parallel to the line. So for example, if I gave you something like this, suppose I gave you a point here, and the point is 2, 1, 3, and it parallel to 4, 0, 1. Right? Then the equation of this line will be 2, 1, 3 plus lambda by 4, 0, 1. Okay? The equation will look like that. All right? That is called the vector equation of the line. We need to go from vector to Cartesian to parametric. All right? I want to show you an example here, how to get each one, right? That is your Cartesian, and underneath is the parametric. Right? So what is here? Right? What's this example here, right? Let's say I gave you R is equal to 2, 1, 3 plus lambda by 4, 2, 1. Right? We need to go from Cartesian to parametric and vector, right? This one here is a vector form. Right? I can expand on R. R is X, Y, Z. If I were to simplify the right side, I will get 2 plus 4 lambda, 1 plus 2 lambda, 3 plus lambda. Okay, what does that mean? That means that X is equal to 2 plus 4 lambda, Y is equal to 1 plus 2 lambda, and Z is equal to 3 plus lambda. Right? This is called the what? Which one is this? Parametric or Cartesian? Parametric, X, Y, and Z in terms of lambda. So for me to get a Cartesian, all I have to do is make lambda the subject in each one. Right? So I have my vector form, I have my parametric form, and I have my Cartesian. Right? Of course, leave out the lambda, right? And just put them equal to each other. Right? You have to be able to go from one to the next, right? Cartesian to parametric, but back to vector. Right. How do you show if two vectors are skewed? Right? Skewed lines are not parallel and don't intersect. Okay? How do you show if two vectors are parallel? How do you show if two vectors are parallel? You have to look at the direction vector and see if they are scalar multiples of each other. And then how do you show if they intersect? Right? Solve solve simultaneously. Which form are you using? Parametric form, and you solve simultaneously. Okay? Last thing you have to remember in vectors is the vector equation of a plane. Here we have it. Right? If I give you a plane, we just need two things on the plane. We need a perpendicular vector on the plane called an N, and we need a point on the plane called an E. All you have to do is plug in A here, plug in N here, and you have your vector form. That's okay? To get the Cartesian form, you just write R as X, Y. All right? Let's go into one time. What's that? No, wait, hold on. Right? So they want us to find the vector equation of the line, and then they want us to determine whether the lines intersect, parallel, or skew. All right? I'll give you a little 2 minutes to go ahead of me, and then I will do it, right? What form is this again? This is the parametric form, right? And then you need to get the vector equation of the line, right? Get the vector and then go and solve and see if it's parallel or not. Right? And then we jump right into PMI. Do some divisibility and summation. And now we have to, after getting vectors, they want to see if it's cube or parallel. Or intersect. Oh, Marcus, where the black marker?
I didn't pick
Your son up here.
I swear on the.
Second ticket. That's what the marker have, boy.
Yeah, but check these buckets. Check this bucket.
Your son up there.
I see.
I think the marker
I
have.
see. I see.
I'll make it up here. That's not, I have more somewhere, let's go now. What we end up with here? So we have L1, x is equal to 1 plus t, y is equal to 2 plus 4t, and z is equal to minus t. L2, x is 2u, y is 3 plus u. Right? So basically, you want to get the vector. So the vector would be 1, 2, 0 plus t by 1, 4 minus 1. Anybody get that? Right, you seen it right here. 1, 2, 0, that's 0.14 minus 1. Everything right here. R here is what? Have no point here, so that's 0, 3 minus 2 plus u by 2, 1, 3. Are they parallel? What do you look at again? You look here, right? At the direction vectors. These are the vectors that give the line direction. Right? So therefore, they are not parallel. So now we're going to check and see if they intersect. Right? We're going to check if they intersect. What is it? Oh, yeah,
What?
Right, so if they're not done, it means that they are skewed.
Yeah, they do it in second.
If they don't intersect, means that it's skewed, right? Let's see. All right, now.
Just because.
Right, so we're gonna solve these two. Right, all you remember, if they intersect, Amber, it means that these two values should be equal, right? So all we have to do is see that 1 plus t is 2u, and we have to say 2 plus 4t is 3 plus u. Right? So these two things, they have to be equal. Now I have two equations I can solve. Right? From here, I can see that t is equal to 2u minus 1. So I'll get 2 plus 4, 3 plus u. So that'll be 2 plus 8u minus 4 is 3 plus u. Bring all the u's on this side. I got what? 7u?
Yeah.
Right? This is minus 2 is 5. So I got u to be 5 on 7.
Yeah.
Anybody got that? So therefore t is equal to 10 on 7 minus 1. So that will be 3 on 7. Anybody got those values? Anybody got those values? No? Yes. Anybody got these? Yeah? Yeah, you know, what to do next? What to do next here on? Right? Next step is substitute the values here and here. Right? So you have to substitute t in here and you have to substitute u in here. So z is equal to 0 minus 3 on 7, which is minus 3 sevenths. And z is minus 2 plus 3 by u, which is 5 sevenths. So that would be minus 14 on 7 plus 15 on 7, which is, are they equal? Are they equal? No. So therefore, it is inconsistent. This implies they do not intersect, which further implies that they are skewed. All right? If when you solve, you got these two values to be the same, it means they intersect. All right? You'll follow what I did to solve. Right? For those who lost, all I did is I used these two values. Assume that these two equal. Assume that these two equal. I got two equations. Solve simultaneously. I got u and t. Then I took u and t and put it in here and here. And those values were inconsistent. Because they're inconsistent, they don't intersect. Okay? And if they don't intersect and they're not parallel, then they are. Okay? Yeah, if they were to be the same, then they would have intersect. Okay, so that's technically we are looking for vectors, right? Next, let's take a look at PMI. That's module 2. Module 1. Let's take a look at PMI. Right, let's take a look at PMI. We do some summation and even. Right? Let's start with the easy one, right? Come on the board, Amber. Come on, try this one in. Real good. Real good. Right? I will do one of the next sample, right? No idea. I am trying for it. Right, so what are the steps in showing what are the different types of proofs again? So generally different proofs are what? Direct. That's like what? Direct is like if you do identities, right? That's equal to right for the direct proof, right? Next one is proof by counter example, proof by contradiction, proof by induction. Right? Sorry? And exhaustion. But you hardly ever get the opportunity to use exhaustion. Exhaustion is where you have to use all. Right? PMI. So what are the general steps in PMI? Right? We have to show it holds for. So you have to show it holds for n equals to the first value. It's not always 1, right? Right? But you can understand what I mean by 1, right? The first value. Then you have to assume it true for. Right? You have to assume true for n equals to k. Then your main step is to show it holds for. Show it holds for n equal to k plus 1. And once you do that, then you can write the last line, which is what? Since it holds for n equals to 1, n equals to k, n equals to, it holds for 4. If you do a PMI and you struggle in this stage, right? You struggle in this stage, you're not getting the actual thing. Just put ... Write what you're supposed to get, and then write step 4. Okay? Step 4 is the final statement, right? Do not assume because you didn't get it out, you just stop there. Right? Because you just probably didn't get part of the simplifying out. So just leave a little space in case you have to come back, and then write the answer you're supposed to get, and then write the final statement. Okay? You should be able to go through past step 3. Regardless of how hard it is, you should be able to go through steps at part 3, right? All right. So I'm going to do an example. Divisibility is generally easier, right? But we'll still do one. Let's do a summation. All right. Let's do a summation here, right? Right. I think no PMI is coming up here. What do you I don't have to write. I don't have 20. Oh, I can try to write it. Right. Let's say we have this. Prove by induction 8 plus 16 plus 24 plus 32 plus 8n is equal to 4n by n plus 1. Right? And it holds for all n is natural numbers. What is here? So the problem with this here is that you don't have information, right? And we need to put in summation. So how do I introduce the summation here? Right, so you put the symbol. So you put the symbol summation of r going from 1 to n. What's the n term? What's the formula that we're using to get all of these? Right? That will be 8r. Right? So when r is 1, again this. When r is 2, again this. When r is 3, again this. When r is n, again that. You're seeing that? Right? So instead of working with this, work with this. What is equal to? 4n by n plus 1. Nice. So I start not r is 1. So I can show it holds for n is 1 now. Take the left hand side, put 8 by 1, you'll get 8. Now go to the right hand side, you'll get 4 by 1 plus 1 is also 8. Therefore, it holds. That's okay? Plug it in the left, plug it in the right. That's okay. Next, you want to assume true for n equals to k. So you have to write the n equals to k statement. That'll be the summation of r going from 1 to k of 8r is equal to 4k by k plus 1. So you'll notice I no longer write n or even k. Right, Christopher? Yeah. Next statement, n equal to what? K plus 1. So that'll be the summation of r going from 1 to k plus 1 of 8r. Just put k plus 1 in here. You'll get 4 by k plus 1 by k plus 2. Okay with that? Yeah? Cameron? Yeah? Right? What's the next step? The next step is a line that works no matter what. So your next step is this. So you start with the left-hand side and you say the summation of r going from 1 to k plus 1 of 8r is always going to be equal to what's in it? What always equals to? What is statement always equals to? It's always equal to the summation of r going from 1 to k of 8r plus d. Right? So no matter how hard the question is, you should be able to reach up to here. Right? There's just the formalities of it. What is always equal to? That. Right? So the summation r going from 1 to k is always equal to this. Right? So that'll be 4k by k plus 1. How do I get the k plus 1 term, Cameron? How do I get the k plus 1 term? Right? To get the k plus 1 term, you put k plus 1 into whatever you have here. Right? So you put k plus 1 as r. So that'll be 8 by k plus 1. Here's where the trouble starts. You have to make that look like what? Like this. Right? As I said, if you're not getting it, especially those who can't factorize, my advice here, expand this out, expand this out. That's be easier for people who can't factorize, right? But this one easy. Well, what can I factor out here? I can factor out 4 and k plus 1. So I'll be left with what? K and plus 2. Done. Right? And then you write your last line. Since it holds for n equal to 1, n equal to k, n equal to k plus 1, then by PMI it holds for all natural numbers. All right? Let's go again. Let's try this one here. Copy it down and try this one in. Well, you got to copy it down, right? Go ahead and copy it. What are you? What up one way? Way up one way. By the plus?
Yeah, yeah.
K plus 1. Where that come from?
And make one.
Factor out. When you factor out 4, when you factor out 4 from 8 until you get 2, and when you factor out k plus 1, you'll get 1. 2 by 1 is 2. Shall we pick up that? Right? There you go again. Right? They told you that S to the N is Anybody writing here? Yeah? No, you're right. In this first part. Try this now. Try this here. 4s to the n is equal to 5 to the n minus n plus 1 minus 1. Right? Try this here. Right? Oh, yeah. This is saying 4 by this, right? Right? It might be easier to put the 4 on this side and then work it out. Right? So it might be easier to work with 1 on 4 instead. All right? But if you don't like it, it's up to you. Keep it done that way as well. Go ahead. Try that PMI there. Tell how far you can reach. Like somebody going to put this one. Okay. I think the name started with E. Right, you have an E and an E. You have an E. Yeah. Try quick. Five to the power. Five hours. Huh? Now you're trying to prove a summation. A summation. So you're trying to show that the summation of this equal to. Right? But I told them instead of using 4, put a quarter here. So it will look just like the last one. What would the summation be, Samson? What would the summation be? Summation of R going from 1 to n of what? 5 to the power of R. Right? Is equal to that. Right? So that is what you're trying to prove, that this equal to this. You think I'm finished already? Yeah, you're on blue or black hammer? Oh, yeah, what else? Yeah, that's good. Fine. That's but how you have seen. Yeah. Fine. Now what it says? That's good. What you keep plus one. Keep plus one, but keep plus one. Well, we have happy. So keep plus one. We have R to keep plus one. 5 to the cube. And it's very fast and right, so there's one small trick that you need to remember is you have a quarter here, 5 to the k plus 1 minus 5, k plus 1 term, put k plus 1 here. Right, here's what, right? The only way that we can combine them, there are two ways. We can multiply the quarter out. It's up to you. You can multiply a quarter by this and a quarter by this. Or, and there's a 1 in front here. So instead of writing 1, I could write 4 and 4. The reason you're playing that is that you should be able to see now that you could factor out what? Quarter. You see that? So if I put 4 and 4 here and I could factor out 1 quarter, I could factor the quarter from here and a quarter from here. And then you'll be able to combine and simplify that. Try it and see. So factor out a quarter from here and a quarter from here. And then it should be able to bring things together and get it out. Yeah, you can expand. Right, factor it out and now. Factor out quick. right? So when you factor out 1/4 from here, you will get 5 to the k plus 1 minus 5. When you factor out 1/4 from here, you will get 4, 5 to the k plus 1. That's okay? What are you going to do now? Dot, dot, dot. Yeah? How much 5 to the k is this? 1, and so if you have 1, 5 to the k plus 1, and you add it to 4, 5 to the k plus 1, how much you'll get? You'll get 5, 5 to the k plus 1 minus 5. Right? 1 plus 4 is what? 5, right? So I get that. And this is 5 to the 1 now. 1 plus k plus 1 is what? K plus 2. That's it. You're good to go. Write the last line, right? No? Because yeah, looking to see for market and when the time outside the 4 5. Oh, yeah. That's one more thing to note, right? Right? You can't multiply 4 by 5 here and get 20, yeah? Because this is an indice. What mass is what? You do indices first, right? So you have to expand this out before you multiply by 4. So you can't do that, right? Next thing is, if you wanted, you could factor it out if you want, but you would get right in. Okay? Do any visibility now? Sorry. Typer, what's up? Try the visibility now. 6 to the n minus 1 divisible by 5. Try the visibility. 6 to the n minus 1 divisible by 5. That one? And then go next one. Next one there. 1 feet, next one. PMI, this one is easy. Right? What you had to do is you talk to the keys and case one. Right, but it's not summation. So you can put it, you can write this as 6n minus 1 is equal to 5e. Right. Oh, yeah. Okay, number is that. Right, if you want in a divisible questions, they could write it like this. 6 to the n minus 1 is equal to 5e. Right, you can do it like that. And prove it, right? I'll do this now. Once you can do one, you can do most. After this period, let's run 2 logs on interest, right? No, I just make up. You can visualize something, visualize 5. Yeah, but it's clear. Yeah, that one. Finish it. Right, so you might have this. Right, when n is equal to 1, you will get 6, 1, which is 5. Right? And 5 is of the form 5 by 1, therefore it holds. Right? You get a multiple of 5. When it equals to k, you write 6 to the k minus 1 is equal to some multiple of 5. Just change the letter. So it'll be a different value, right, Amber? Right? And then here, what to do here now? Right? You have different things, right? You can make 6 to the k the subject of the formula. Right? And then here, n to the k plus 1, that will be 6 to the k plus 1 is minus 1. This should also be divisible by 5. So you write 5, a new number. Change the letters, right? To be a different letter. Now, left-hand side, you started with 6 to the k plus 1 minus 1. Right? We can simplify that. That'll be 6 multiplied by 6 to the k minus 1. And we know what 6 to the k is? We know 6 to the k is 5b plus 1. That'll be 5b plus 1 minus 1. Then you multiply this out. That'll be 30b plus 6 minus 1. That'll be 30b plus 5. Once you reach here now, you can factor out 5. Right? And now this is of the form 6c. Right? Is of the form 6c. What that means is there's a multiple of 5. And that's it. Write your statement after that. 5c, looking like a 6. That's not possible. Right, let's go again. Look at some logs and I'll give you a break. Right? No break. No break again. That was the last break earlier. Well, I lied. No more break. Yeah, Jacob. Yeah. Right, let's take a look at some logs in the C answers now. Ready? Right? You remember your log rules? Right, so there's some rules to remember. Square root of xy is root xy, right? You can write a surd like that. Same base, we add the powers. Same base, we divide and we subtract. A to the minus m is that. A to the power 0 is 1, right? Should know those things by now, right? Right, you should know these rules by now. Next, right. What you will notice here is that instead of me writing the log rules, I wrote the ln rules. Because log and ln are the same thing, right? Right? What is ln again? Right? Log to the base e. It's called natural logs, right? That's ln. So every time you see ln is really log e. So whenever you see ln e, it's log e to the base e. That's why ln e is 1. That's okay? So the reason why ln e is 1 is because log e of e is 1. Right? Then sometimes you might see this ln e of 5. I will say the answer is 5, right? I can bring the 5 in front. And what is ln e? 1. That's the reason why, right? Because ln is log to the base e, so it follows all the log rules. Right? By the way, how do we sketch these graphs? What's the graph of e to the x and log e to the x look like? Yeah? What do graphs look like? Right? E to the x looks like that. And log looks like this. Right? So this is a to the x and this is log a to the x. So right? So what does that say about inverse? This is f of x and this is the inverse. What does that say graphically about f of x and f inverse x? They are reflections along the line. Right?
So log of f of x will be the same as inverse of f of x.
Right? So for example, e of x is here and ln x will look like this. That's okay? Ln x will look like that. So e of x is there and ln x next side, right? They are inverse of each other. Okay? So you have to know the graphs, right? And same as before, same base and the powers, right? Same base addition, you multiply and then you divide and so on. Right? One of the new rules I want you to remember about is this rule here. What is called a rule? Change of base. All right, so when you use it, when I want to change the base, right? Right, when I want to change the base, you use it. All right, nice. So, right, here you have the graphs as well, right? And you have your asymptotes and so on. We do functions just now. Try this here, we're doing hard ones, right? Right. While you're waiting, just solve this, please. Solve that here. Solve that here. I can finish first, get money.
So, I have only going to choose the
What did I lie about?
for the
We do it yet?
maybe let's say the
Talking about, right? I don't remember. Solve those two. I somehow I want to give you after. Solve those two in the meantime. Right? This here is the what? Here's the what? And this guy's quadratic. Alright? And then this guy is quadratic. You do after. You got. Right, so you can probably let y equal e to the x. So you'll get y plus 1 on y minus 2. What to do now? Huh? Multiply everything by y. Y squared minus 2y plus 1 is 0. Right? Now we all wired up and we have a quadratic. So that's y is 1 value alone. Yeah. And are we done? No, we had to put back e to the x is 1. Right? So we know x is 0. Right. So what's something that Yash did, right? And what you all think? I never say what's wrong. I tell you, I didn't tell them. So what you say? There is no rule, right? There is no rule that looks like this, where you could take ln on each term. Again, it looks nice, but that's not a rule, right? Because if I apply plus here, you had to multiply and then divide, and you wouldn't get the same thing. All you could do is this, though. If you wanted, you could have taken ln of this, and then ln of the whole zero. You could have done that if you wanted. It would help you, but we could have done that. Okay? You can't take ln of all the terms individual. That's not a rule. It's ln on both sides. It's ln of everything here, ln of everything here. All right? Try that one there. Try that there. Use the rule properly and you'll get through really easy. Really. Give it easy question. You gotta solve it. Solve it. I don't I tell people like how you have really kind of Right, so here we have what? Here we have log to the base 2x to the power of a half, right? Can I bring the power in front? No, that's not a rule. Right? But here now, this is to the power of a half, right? Can I bring that half in front? Yeah. So now I have log 2x all to the half is equal to 1/2 log 2 to the x. That's okay? So this and this is, sorry, the half being here is not the same as the half being here, right? Okay? Only when it's above the term, then you can bring it in front. All right? What to do now? Yeah, you stop there. You can do enough. You square both sides here. But to make it look a little easier, let's do what we did on that side. Let y equal to this. So you'll get y to the half is equal to half y. Right? And as you said, what to do? Square both sides. What you'll get here? What you'll get here? Right. When you have questions like this, right, don't cancel out the y, right? It's into a quadratic and solve. So you'll get y squared, multiply everything by 4. You'll get y squared minus 4y is 0. And now you'll get two solutions. If you were to cancel off y's here, you'll get one solution. Right, so your objective is to always make the question look a little bit easier. If you can make a substitution, make it one. Yeah. Solve that, right? How much you all got?
60.
You got?
60.
You got 16?
Oh, not there.
Not there.
Four
So,
and zero.
4 and 0.
And zero.
Right. And then you have to find here. Log 2 to the x is 0. So that means x is 1, right? And here, log 2 to the x is 4. So that means x is equal to what, 16? X is 16. Let's go again. Are you okay here? Are you okay here? No? Where you get lost? Follow here? Huh? Where you get lost, madam? Oh, okay. Right, next one there, Bradley. Carry out there. Let's go here. Yeah. Yeah. Try part 2 and part 3. Look out the time part 2, part 3, I mean. That was my first. I'll sleep you out.
Everything constantly, plus lost things
Now, let's check out the first one. First one easy, right? First one straightforward because they are the same what? Same base, right? So you will get log to the base 5 by x plus 3 by x minus 1 is 1, right? Convert to exponential form, or you can put a log 5 thing on that side, it's up to you. And you'll end up with 5, right? cross multiply, solve, you get x is what? X is 2 1,
-4.
right? But -4 is not valid in the first equation, right? Right? So the only answer is x is 2. We can't find log of a negative number, right? Right, M&M's. How we doing part 2 with no calculator? M&M. Yeah, M&M. How we doing? M&M. Yeah, right. All the same base. And addition means they can multiply. Good job, M&M. Right? And what you recognize happening now?
That is not basic. Yes, I really didn't see basic. That's different.
Basically, and the 2 and all the values canceling except for the what? Right? So the answer is what? -1. Right, like go again. What do I quick again?
Yeah.
Yes, sir, please.
What we gotta do again? Functions and we have functions and cubics. We're gonna work 15 minutes, not half an hour, right? 15 minutes and then we do functions. Right? What are some models? Well, people who want to stay.
I need after one, please.
Yeah. Fifteen minutes, huh? Start about 4 o'clock. All right, let's go. Right, so take a look at functions, right? So let's just go over some of the rules that we need to remember, and then we can try to do questions, right? All right, let's take a look at functions. All right, so for function, you should know the domain, right? You set up all the x values, and the codomain is, right? You set B, and the range is set up all the images, right? Just small definitions you have to remember. Here you have a vertical line test, and of course you have the horizontal line test, right? If you look at the example there, the vertical line test was one of the ways to check and see if it's an actual function, right? What's the problem with the first one there? Why is it not a function? Why is it not a function? Huh? Right? So what type of mapping is that? One to many, right? So it has to be a one-to-one or a many-to-one to be an actual function. Right? How do we show something is injective? Two methods are what? If f of a equals to f of b, then a equals to b. And the next method is the horizontal line test, right? Don't just say line test, right? Horizontal line test. What will happen if it cuts the line, if it cuts the function more than once? Right? It's not injective, injective, right? Next, we have onto a subjective. So you have to remember that every y value is mapped to at least one x, right? To show something subjective, we have to show that the codomain and range identical, right? Right? We can also do a line parallel to the x-axis and check and see how much time it cuts, right? What would happen if a function is both injective and surjective? Right? It's said to be what? Bijective, right? Right, nice. So you need to remember these little things here. There's a question long ago, old one, that they gave you this. Right? And you have to remember that if you go this way, that's f of x. If you go this way, that's f inverse x. So what they want you to remember here, they want you to remember that the range of f of x now becomes the domain of f inverse x. Okay? There's some smaller things to remember, right? And what would the range of f inverse x be? What would the range, and based on that small diagram, what would the range of f inverse x equal to? Right, so watch it back. So the domain of f inverse x is the range of f of x. So my question is, what is the range of f inverse x? The domain of f of x. Right? And the only way a function could be the only way a function can exist that it must be, right? It must be bijective, right? Right? After that, These are three graphs that we need to know, right? These are three graphs that we need to know, right? That graph there is modulus, the 1 on x, very important, and well, 1 on x squared. We have to learn that graph and all the possible transformations. So I'm going to do it for you now. I know you're tired, right? I'm going to just run through all the important transformations, right? Oh, no. That's all. You can message me now. Right? Message you. I have to move. I have to move. Please, sorry. No, go, no way. Right? Ready? So one of the some of the functions that we need to remember, y equal to x, right? We need to know y equal to x squared. And we need to know, well, we know x cubed, right? Y is equal to x cubed. And we need to know 1 on x, right? Y is equal to 1 on x. Here's when x is more than 0. Here's when x is less than 0. That's the most popular, right? Right? We need to know a couple of transformations. So if I say, well, here's what, draw for me now, y is modulus of x. Modulus of x means that this part of the graph don't exist. So we're going to reflect it up here. Right? While we are on modulus, we should know the definition of modulus. Modulus means what? When x is more than 0, we leave it as it is. But when x is less than 0, put a minus in front. Right? So whenever you're solving modular questions, you can use this. So if I ask you to solve x squared plus the modulus of x minus 2 is 0, the way to solve this is to use the rule. Right? You can do it too. You're doing it twice. You're doing it when it's positive. You're solving the quadratic when it's positive. And then you're solving it when x is negative. Right? So whenever you have a modulus, solve it with whatever in here positive and whatever in here negative. Okay? Whenever you have a modulus. Or if you want, you can square both sides. Right? But it's a little bit harder in questions like this when you have to square both sides, right? Let's say now here, I said to draw y is minus x squared. Minus x squared now is a transformation that reflects in the x-axis. So it looks like that. That's okay? So you have to learn all the transformations, right? What would happen? What would happen here? Well, you mightn't see it, but what would happen here? If I put a minus in front of the x, the whole function, it will reflect in the y-axis. But if I reflect this in the y-axis, how it will look? Same thing, right? Because it's symmetrical, right? If I reflect this here and this here, it will look just like that, right? And it should seem logical because if I work this out, again, back up. Are you okay with that? Right? But if I put a minus here, I will reflect it and get out. That's okay? Yeah? If I reflect this in the y-axis, I'll get this line. Are you okay with that? Well, cool. Here's the important one. This function has something called a asymptote. Right now, the asymptote is the x-axis and the y-axis. Correct? So if I take 1 on x and I add plus 2, what does that mean? Taking the whole function and shifting it upwards 2. Right? The function is now twice as big. So I'm shifting everything up 2. Are you okay with that? What would have happened now if I put minus 3? Shift it where? Right. Right? Minus means it's shifting to the right. Plus means it's shifting to the left. So if I wanted to do this as a graph, here's what I'll end up with. Shifting upwards to my asymptote. That's what I'm about. I'm right here.
Oh,
Huh? All right. So we're gonna carry the graph upwards, so it becomes the new asymptotes become what? If I go 2 upwards, it becomes y is equal to 2. And if I shift it to the left 3, it becomes x is minus 3. That's okay? So I shift the graph upwards and to the left 3. So now my answer will look like this. No, that's a plus. Make a mistake, right? I make a little mistake there, sorry. Right? Shift to the left 3 because it's positive. Right? So positive here, shifting to the left, positive here, going upwards. So what Brandon, what forget the name, right? Dylan. What Dylan gonna do now for me is Dylan is going to try to sketch this. I'm getting nothing too hard, Dylan. Sketch that. So tell me the shifts first. Wait. No, let's tell me the shifts now. I want to make sure you're gonna do it right.
No.
No, they won't see you, it's just the board. They won't see you. I'll show you the video first.
Alright.
On TikTok. Watch. What does mean now? Minus 2 means shifting where? Up or down?
Down.
Down how much?
2.
2. And here's what? Shifting to the right 2 or to the left 2? No. Positive was 10. So negative to the
Right.
to the right. So I just catch that from a quick.
Boom.
All right.
Right. You know, we are shipping. To the right to. Oh, this is okay. This is okay. So we have 2 up. Right? We have 2 up.
I thought it's
No,
down.
lie. There are 2 down. And you have 2 to the right.
That should remind us to us.
Oh, yeah.
Draw the line. Draw the line.
True.
Like how I have it here. Draw the line. Oh, you know that. You're drawing the horizontal line here.
Oh, you're doing 2.
Yeah, you're drawing the asymptotes.
Oh.
You have to label the asymptotes, right? What's this one here?
This one is down. This one. 1 minus x.
No, that will be x equal to 2.
So,
What's the line here?
this x, you know, y
Y
is equal to minus.
Right.
Oh.
And then sketch it. Sketch, put the shape in the middle. Put the shape.
Oh. Boom. Ah, no, so. No, so.
Here. Yeah, asymptotes here. I'm going to take the whole graph and bring it here. Yeah, I have that. Right? Right, but this nice and easy, right? Suppose it looks like this. Suppose instead of like this now, right? Suppose instead of seeing it like this, you see it like this. Suppose it's something like that. Yeah. Yeah. Suppose it's something like this. What you gonna do? Huh? If you see it looking like this, you gotta long divide and make it look like this. Right? If you divide this into this, you will get this. That's okay? If you see a function looking like this, you gotta make it look like this, so it's easier for you to see the transformation. That's okay? Right? So all the transformations you need on the summary, right? On the summary, you have all the transformations that you need to learn. What is money page? Tell me what you think. Right? How we solving this? We're just talking through, right? We're just talking through what's the best way to solve this.
Fair both sides.
Square both sides and solve it, right?
Yes.
If you want to use the rule, you do it with a plus and then with 2 plus and then a plus and a minus. That's all. Right? If you don't want to square it. So with 2 plus sides on either side and then minus side. Christopher, yeah, no problem. Christopher, help me out here now. Right? These are easy functions. Come on to do here now. We can talk it out. Christopher, stand us up. How to show it 1 to 1. You can do the horizontal line test. Or for the next method. Yeah, what you can do? F of A equal to. So we can check and see if F of A equal to F of B. Right? We can see if A equal to B. So you'll get 3A minus 2, 3B minus 2, 2 will cancel. Divide by 3 and you'll get A equal to B. So what that means? It means that it equal to what, right? How are you working out F of X? How are you going to work out this? How are you doing that? Put F of X in and then put X plus 3 enter and then solve it, right? That's okay? Right, so get that from the induction. That's kind of get about it 20, you know, why to have oh, wait, one little rule here. What does this always give you? What I always give you? F of F inverse and F inverse of F always give you what? It always gives you back ends, right? Right? Always give you that's a rule, right? If you find F of F inverse, you'll always get back ends. Right? This question I kind of needed for this one. Let's just go through this one here. Look at that function this. See that? Question. Watch it there. Keep watching it. You can see the asymptotes.
Yeah.
Tell me what the asymptotes fit. What are the 2 asymptotes of that graph? Yes. Right, y is 0, nice. And x is? Nice. Nice, 8, nice. Right, and you'll see in y, right? They shift the graph where? They shift the graph 1 to the right. Okay, Let's see what they want now. Let's see what they want us to find. On your answer sheet, sketch G inverse. Sorry. Sketch the modulus of G. Sketch the modulus of G at f of x minus 1. Right? Can you help me out? Sketch the right. Can you help me sketch the modulus? How's it? Right. When you're sketching, right? When you're sketching, you don't have to make it too random, right? Remember, if you're sketching the x-axis, what has changed? If you're reflecting the x-axis, what has changed? The y value changes, sign by the x value. So what you can do is along the graph, we have about 5 points. Plot that and then sketch it, right? So you do something like this. Right? Then it looks a little bit more symmetric, right? But it will be somewhere up there. Right? So try and get about 3, 4, 5, 6 points, plot it, and then connect them. That's okay? And then let's pretend you have to draw a line. Let's pretend that's the line. What is the solution now? Question says draw some random line. Question said to draw the line x minus 1. Draw f of x is x minus 1 and then solve that. So let's pretend it. Let's pretend the line was the line I drew there. How you get the solution? Yeah. Where the line meets the right. Where the line meets the function. Right? Where the line meets the function will be your solution. That's okay? Huh? Here and wherever. Here. That's all right?
Oh, yeah, it should be modulus.
No, not the modulus. Here of x actually. So if the line looks like that, the answer is here alone.
Okay, we have to be of x.
So you have to G of x. Right? So you have to solve G of x equals to f of x. So graphically, if you have to solve two equations, sketch them and where they meet the answer. Right? Where do you want to come? No. Oh, I find one.
Exactly.
Read it off the graph. So when you draw your line, and it could be speed of the point where it is. You get the equation of the line. Right? Yeah, yes, that. All right, nice. Right, then what did we have? One more function, right? Because if you look at the recent years, you see in petty graph, it's catch something, right? I want to make sure you can do it. Right. If you look there, you have g of x and f of x. Right? You'll see the answer. I want to pick somebody, right? You want to pay attention. I'll pick you, right? What's up? Everybody okay with that? So those are the functions. Sydney, they give you the function, right? Actually, no, not here. Sydney one. Sydney, power join in modulus of f of x and g of x. Power join now. Power join in modulus of f of x and modulus of g of x. How will you have to what you do again? Right, you will reflect this part up here, and it will reflect this part here. Right? Right? Reflect the part below the axis, above the x-axis. Okay? And then how we doing this part here, monkeys? How we doing that? Which one? Last part. Solve the equation. Huh? Oh, graphically. Hence. How you gonna solve that?
This one, right?
Right. I don't know how you're gonna make it do it from here, but what you're supposed to do? Draw both graphs together and see where they intersect, right? But because these graphs are not together, you will have to do the otherwise. Square both sides and work it out. That is the book. Yeah? Get it up? Why? I just thought of it. Sounds the how it is. Right. Do this mentally after now. Right, what's the next one there, Olivia? Right? How are we doing that? We got mentally, no books, no writing. Who get the answer first? Getting something. Huh? Mentally, no writing. What is that? And can you put it in? What's the name again? Right? Again, it's the same rule I just showed you, right? The rule I just showed you to back that answer. But now,
Yeah, but the actually increases. Increases that, yeah.
how are we doing that? What this says here, based on the rule I gave you. One, that'll be one, right? F inverse of f of one is one. That's the rule I gave you here. Right? So now you are to find f of one. But they gave you f inverse. So what to do? Find the inverse of that, right? That makes sense? Find the inverse mentally for coming on. X what? X minus 1 squared minus 1. Carry across the 1, square both sides, and then carry across the next plus 1. And then when you plug 1 in here, the answer is right. I'm gonna show you again. You have to find f of x here. So f of x, of course, you do it the long way, right? If you have inverse, how you get my f inverse each other?
If you have inverse, what do you get about f inverse?
If you have inverse, how you get f of x? Right, you do the normal thing, right? Let y equals to f of x, interchange, and so on, right? And the answer will be, I'll just tell you what the answer is, right? Right. So my question is, what is this long thing here? Right? You have to focus on here first. And use the rule f inverse f of x is x. So if x is 1, the answer is 1. So now you are to find f of 1. Plug a 1 in here. 1 minus 1 squared is 0 minus 1. So the answer is minus 1. 0 minus 1 last time we had. Really, Marcus, really. Okay with that? Yeah, so that's functions. Right? What about alpha, beta, gamma? Well, let's go on through this. Well, easy, that has not filled it out, right? When I call you, I want you to tell me the whole column, right? Two, amber. Tell me the whole column. True. Wait, I get lost. True, then what? Then. All right, nice. Next one, set. Nice. True. Next, Jiran. True, false. What's the next one? False and then true and true. Next, Jiran. True, false, true. Wait, I missed one? Which one is false there? Only have one false in there. Right? There's only one that's false. Right? And last one, Joshua, Sandu is now here. Last column. Sandu. Yeah, that's Take it time, Ready? True. False. Nice. Question. Are these two logically equivalent? Brandon? Dylan? No? No? Nice. Very good. Right, get a nice visibility or try. Let's go again, yeah. Last year, alpha, beta, gamma question. I'll get somebody to tell you. Try this one here, please. Wait, no, not up. Okay, fine. No. You gotta find all these equations and you gotta find the equations and then Right, ready? Are we showing associative here? If they give you yeah, you have to introduce the next variable. So you have to say x star y star z, x star y star z. You have to work out this, right? And then you have to work out this and show that here and here equal. That's okay. A little bit low, by 6 marks. Right, associated 3 variables. So you have to introduce one more variable. Right, so x star y now becomes x and c becomes the y. So it becomes this. Right? It'll become like this. X star y is now c, right? Multiply by c all over x star y plus d minus e. Yeah. Yeah, let's go see. Commutative is what? And distributive is what? 9. Yeah. But you're not done here. You're not done. You still have to plug in this. You still have to plug in the whole thing and simplify it out. Alright? So you still have to plug it in and simplify it out. Right, alpha, beta, gamma. Let's just talk this through. How you find the sum of the roots? How you find the pairwise sum? How you find product? Right, and then you work on the value from that, right? How are you going to find out? Right, you'll recognize it all the years the given it is, right? Right? How are you going to find an equation now whose roots are this? What you have to do? X cubed minus the what? So that's 1 on alpha squared plus 1 on beta squared plus. How are you doing that? LCM and work it out, right? Very good. Plus the 1. How you do pairwise sum? Right? Pair them up and then add it, right? Right, Ishana? So that's 1 on alpha squared beta squared plus 1 on alpha squared gamma squared plus 1 on gamma squared beta squared by x. That's okay? Pair them up, let's sum it up. And last part is the what? Last part is the product. I can't really fit it, but you know what it is, right? Alpha squared, beta squared, gamma squared. That's okay? How are you going to simplify this so? How you do? Find the LCM. What's the LCM? Alpha squared, beta squared, gamma squared. Right? And then what the numerator will be here on? It will be alpha squared plus beta squared plus. Same thing like all the others, right? Very good. And you plug in your answers and you're good to go. All the way on 2024. Huh? It was? No, I think I have it here. Right form. But we did it in the crash course for sure. Right, 24. All you can handle that. F of G of X. Yeah, easy. All you can solve this. Yeah.
So what's the thing? So I know if it's
How are you doing this? Change your base, right? Nice. How are you doing this? You have to show it. Right? Injective and surjective. Nice. Right. This is what you're talking about here. Right? This one even easier than the others.
yeah.
Right? Because all you have to add it up and you'll get alpha plus beta plus gamma minus 1. Sorry. Minus 3. And then you do the pairwise sum, multiply this by this, and they give it to you right here. The answer is 12. They give you the pairwise sum. And then product, you have to multiply it out. Right? Then multiply the whole thing. So it's not difficult on the other. So you can try and set it over. Right? So you'll recognize there was no PMI, there was no thing, right? So hopefully you get some else, you get some PMI something. Huh? I mean, right, well, remember for those who come to my lesson, we start back as soon as that is finished, right? We start back as soon as school finished, right? Right, that's 2 weeks in July, right? 2 weeks in July. And you can log in your Wi-Fi, right? What can get me? One out.
So what is schedule?
Do that.
So what is like 175?
You can see how the 6 sessions that we had to do out. What are the differences? Right, next one. Well, you can handle that. Yeah, basic, right? Well, you can handle that. So it's 2024, 2025, but okay, so far. Right? And then, well, we can show that, right? And then solve it. Prove that. Yeah. Underneath it, what? Difference of 2 squares, right? And then you expand and you work it out. Well, you can handle the equation of plane. Yeah, how are you doing that? Right, you multiply point by the perpendicular vector, right? And then you find the angle. Wait, how you find the angle between 2 vectors? Cos theta, right? But suppose you have to find the angle between a plane and a line. I don't know. Well, what is it A and B? If you have a plane, so suppose you have this, right? Suppose you have a plane looking like this. That's fine, that's fine. All right, that's fine. That's not. Right. Suppose I want the angle between this plane and this vector here. What is same formula? The formula not changing. Cos theta is A dot B over mod A mod B. What is A and what is B? What you're using for A and what you're using for B? Remember, you're using the direction vectors, right? Right? So you're using here direction vectors and you're using here. So you're using 2, 1, 3 and 4, 2, 3. And that's okay. You're not using the points on the line, you're using the direction vectors to find the angle. All right? So remember that, right? Because you'll need that in that last one. Right? So that's in module 2. Module 3, or you can handle that. Or you see the thing yet, for the ball. Right? Or if you do that, find the limit. Find f of minus 2. What f of minus 2? Do it mentally. Very good. Right? How are you doing this? Right? Divide by 4 in 1 and divide by theta in 1. So mentally, what's the answer? 1 and 4. Very good. Right? You can find stationary points. Yeah, easy. And then get the graph up, right?
Yes, you got.
How you find the volume generated here? How you doing that?
Yeah.
You have no limits. You have no limits, so how you get any limits? Solve simultaneously, right? And then integrate between them, right? How you doing this? Yeah, 29 down and separate it up, right? Or if you get everything right before, just leave out us, right? Right, but ideally, what you have to do, right? Gotta find the area, and the part below the axis, what you do? Put a little minus sign, right? No, the part below the axis here, part below the axis, you like to put this one next to kind of one. To make sure, because remember, I just making up something. If the area here is 2, and the area here is minus 1, if you add it, you will get 1. So why it is good for minus in front, so you'll get 2 plus 1 with this 3. Right? Right, and then well, the rest is just basic integration. How you solving this? How you solving that? What's this again? Right, that was dy dx. So how you solving this here? Right? Technically bring all the x on one side and solve it, right? That's okay? So you can divide everything by x cubed and then solve it. That's okay? That's it. Right? So you're going to see 4 questions that you can do real good. Right? The objective is to be sharp enough to do the hard questions and see mark example. Right? Right? Okay, so nice. What do I want to do? What now? So good for money, you can do that now. What else? What is that? What do I need food for money? I know, great. The great will be done. What do I need food for money? That's not. I think I have one here that I'm willing to give money for. Hold on. That's now tell you. I think it's module 1. Yeah. 50. Yeah. Wait. Hold on. Just now. I think I have it here. This man interfered my thing and shift it up. I think he move it out. Yes, man, mix up my thing, right? Did I be right here? Now scene review on module 1, 2, and 3. But that is it, right? That's not out there, that's not. Oh gosh, I need to see if it is. Log in. I think that's not it, but we can still do it. Alright, I know. It's not the only we can stop for the 9 interested. We had to get at least 15 people. I'm not sure if there's a result. It's the only way we start out to tell you. Oh Lord. Yeah, when you're leaving, just take all the garbage and drop it in the bin in front, right? Ready, let's go. Anybody else join us? No, there's not. There's no come. No, there's nothing. There's nothing. Let's do this for free then. Yeah, buddy, to get serious.
Boxing on.
Right? Minus is the inverse of addition, right? What's the inverse of division? 1 over, right? Yes, you gotta put it down. I used to look out.
Yeah, you press it. No,
About the
Oh, very good. Good see. Next one, boy. I know he's a man who sees when it's money. You see money and all you.
Yes. Yeah. Yeah.
Nice, let's see what's going on here. Extra gas. That's holding on to this thing, boy. What's this here? Hey, hold on here, boy. Hold on here. Last one. Yeah, pressure here. Pressure here. This will separate the sheep from the goat here. Gotta work out all. Ascending order, yeah? Ascending order. Second and third getting something, huh? Yeah. Better look them up.
No! Oh, you even I did that. Hey, wait. That'll be last 10 seconds. Wait, I had to the last one. I still need to recycle.
Right, third place. Dylan, come. Finish.
What?
And
You just want to get scores?
yes. Dylan.
Yes. Second. 5 minutes.
You come third, huh?
No, I come second. After the he gets people what that he can assume that.
Real guess, so you can get to multiple choice. Hey, for the garbage. Yeah, garbage. That's good. You went to my place. For the choice here.
For the garbage. For the garbage. Anybody want our red fun? No.
Yeah.
It's come for what, boy?
Huh?
You come here, you come to find in the morning.
Well, that was a warm up.
There's nobody to try.
You want mine?